Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will take us into one of the most mysterious truths about existence. Why everything in the universe is spinning, and yet you feel perfectly still. From the turning of planets to the hidden spin of atoms, from the swirling of galaxies to the rhythm of your own heartbeat, rotation is everywhere. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always a joy to see all the little places we gather from, each in our own tiny orbit around this vast world. Now, dim the lights, take a slow breath, and let the gentle hum of the universe settle around you. If your mind begins to drift, that's perfectly fine. The universe itself is always drifting, softly turning, quietly unfolding. Have you ever wondered why you feel motionless? Even though the ground beneath you is spinning faster than a jet, the Earth turns at over 1,000 miles per hour at the equator, orbits the Sun at nearly 67,000 miles per hour, and carries you along as the entire solar system sails around the Milky Way at almost 500,000 miles per hour. And still, your coffee doesn't ripple. The air doesn't rush past your face. The stars above seem calm and unmoving. It's one of the quietest paradoxes of all. Motion without sensation. The reason lies in one of the simplest yet most powerful ideas in all of physics: inertia. Isaac Newton described it centuries ago, but it's something your body has known all along. Everything in motion stays in motion unless something disturbs it. You, the air, the oceans, and the mountains all spin together with the Earth, locked in the same silent rhythm. There's no push or pull to remind you that you're moving, no sudden shift to wake your senses. To feel motion, you need change, acceleration, friction, vibration. But the Earth's rotation is steady, ancient, and perfectly smooth. You're part of its stillness, not separate from it. Astronauts aboard the International Space Station know this sensation well. They orbit the Earth every 90 minutes at more than 17,000 miles per hour, yet inside the capsule, everything feels calm. There's no wind, no resistance, only the soft glide of perpetual motion. Scientists call this uniform motion. You feel it too every time you sip tea on an airplane moving hundreds of miles per hour. As long as the speed stays steady, motion feels like rest. Only when turbulence breaks the flow do you realize how fast you're truly going. The same is true for the Earth itself. No sudden tremor, no resistance, only a perfectly balanced drift through the dark. Our senses simply weren't built for this scale. The delicate system in your inner ear, the vestibular labyrinth, detects acceleration, not steady movement. It keeps you balanced when you walk, run, or climb, but it's silent when the motion is constant. That's why you can feel the start of a car but not the highway's long hum. The entire planet moves with you, and you move with it, wrapped inside an invisible harmony. The quiet you call stillness is the sound of everything moving together. And yet, though you can't feel it, scientists can measure it with extraordinary precision. In 1851, a man named Léon Foucault hung a long pendulum from the ceiling of a Paris observatory. As it swung slowly back and forth, the ground beneath it turned with the Earth's spin. After a few hours, the pendulum's path seemed to twist, not because the pendulum moved, but because the planet did. Standing near such an instrument is like seeing time itself in motion, each swing a whisper from the turning Earth. That same rotation is not just a curiosity, it's the quiet machinery that keeps our world alive. Because of Earth's spin, we have day and night. Because of its turning core, we have a magnetic field that shields us from solar storms. Without that constant motion, one half of our planet would freeze while the other burned. Even the rhythm of the tides, the weather, and the migrations of the living things all depend on this continuous patient spin. Over billions of years, the planet's pace has changed only slightly. According to NASA, the moon's gentle pull is slowly lengthening our days by about 1.5 thousandths of a second every 100 years. You'll never notice it, but each century the Earth's rotation slows just enough for time itself to stretch a little longer. Our planet is still spinning, just a bit more slowly than when dinosaurs watched the same sky. And Earth isn't alone in this great cosmic dance. The sun too turns, once every 27 days, dragging its magnetic fields through space like glowing threads. The Milky Way, our galactic home, spins once every 230 million years, carrying hundreds of billions of stars in its spiral arms. Even galaxies born only a few 100 million years after the Big Bang, those faint smudges now seen by the James Webb Space Telescope, show signs of rotation. It seems the tendency to turn is written into the universe's very fabric, a rule that everything follows but no one feels. If we could somehow sense it, if we could feel the pull of the sun, the twist of the galaxy, the long slow curve of the universe itself, our perception of time might unravel. Because motion and time are not separate things, one gives birth to the other. As rotation defines the cycle of days and years, it also shapes the flow of time itself. To turn is to measure. To move is to exist. So tonight, as you lie still beneath the sky, remember that stillness is only an illusion. Beneath your calm breath, the Earth is spinning. Around that spinning Earth, the moon drifts. Around the sun, your planet races, and the sun itself circles the heart of the Milky Way. Every atom inside you too turns quietly in its own way. The silence you feel is not emptiness. It's the perfect balance of everything moving together. Take a slow breath. You're gliding through a cosmic river, gently, constantly, endlessly. And in that smooth, silent motion, life finds its rhythm. As we drift further into the story, we'll follow that rhythm backward, toward the moment when all motion began, the first turn of the universe itself, when stillness broke and time was born. When you close your eyes at night, the world doesn't pause with you. The planet keeps turning, steady, patient, unwavering. As you drift into dreams, the Earth carries you eastward through the darkness, its oceans flowing, its atmosphere gliding, its core humming softly under miles of stone. You don't feel the motion, but you're part of it, folded into the rhythm of a sphere that spins once every 24 hours, every turn a promise of dawn. If you could see it from space, you'd watch the shadow of night sweep gently across continents, the slowest wave imaginable. Every second, 1,000 miles of Earth roll under that border between sunlight and starlight. It's a rhythm so regular that all life, from the tiniest plankton to the tallest trees, has learned to live by it. And yet it's also a fragile balance, a choreography that has been refining itself since the world began to cool. Scientists tell us that the length of a day, the time it takes for the Earth to complete a full rotation, isn't exactly 24 hours. It's a little less, about 23 hours, 56 minutes and 4 seconds. Astronomers call that the sidereal day, the true measure of one turn of the planet relative to the stars rather than to the sun. The extra few minutes we add are the time the Earth needs to move slightly along its orbit, bringing the sun back into the same position in the sky. It's a small detail, but it's one more reminder that time itself is not an absolute. It's something we build from motion. When early humans first watched the stars, they must have seen them as constant. Yet, beneath their feet, the ground was moving faster than any creature could imagine. The night sky has always been a mirror, and the motion of the stars across it, the great wheel of constellations, is not their journey, but ours. You're spinning beneath the stars right now, watching their light slide silently over the curved horizon. The stillness of the night is only the gentlest illusion. This steady rotation shapes everything about the Earth we know. It defines the boundary between light and dark, creating the days that feed our sleep and waking. It stirs the atmosphere into motion, giving rise to the winds and the great cycles of weather. And deep within the planet, it helps power the magnetic field, a shield made of invisible lines, deflecting charged particles that stream from the sun. Without that field, the Earth would be exposed, its air slowly stripped away by solar winds. Mars is what happens when rotation and inner motion fade. Billions of years ago, its molten core cooled, its magnetic shield vanished, and the atmosphere was blown into space. Today, it's a world of silence and dust. Proof that spin is not only motion, it is protection. The same iron core that turns beneath your feet keeps you safe from a storm of radiation millions of miles away. The connection between rotation and life runs even deeper. Because the Earth turns, sunlight and darkness are shared. Heat is distributed, winds circulate, and the oceans breathe in vast, slow tides. Without that daily change, one side of the planet would roast forever under unbroken sunlight, while the other froze in endless night. Life as we know it could not survive such extremes. Instead, our spinning world gives us seasons and balance, a constant exchange of warmth and coolness, of light and rest. Even the weather's wild beauty, storms, clouds, and waves, owe their shape to the turning Earth. As air moves across the spinning surface, it bends, curving into patterns that sculpt hurricanes and trade winds. Scientists call this the Coriolis effect, but you can think of it as the Earth's gentle handwriting across the sky. It's the reason storms swirl, why ocean currents loop and twist, why flight paths bend over the poles. Every breeze that brushes your skin is written by that same hidden rotation. If we could somehow pause the Earth, freeze its motion for even a moment, the result would be unimaginable. The oceans would rush toward the poles, the atmosphere would collapse into chaos, the very crust might tear and shift as the planet lost its equilibrium. The world would not end with a roar, but with a long collapsing sigh, the sound of motion leaving the stage. And yet, even as we live inside this perfect rhythm, it's changing. The moon's gravity pulls at the Earth's oceans, slowing the planet's spin ever so slightly. Every century, our days lengthen by about 1.5 thousandths of a second. It's an imperceptible change, but over billions of years it adds up. When the dinosaurs walked under the same stars, their days were shorter than ours, roughly 23 hours long. The future too will move more slowly. One day, the Earth and Moon will lock in a silent partnership, always facing each other, their spins balanced forever in mutual stillness. That thought might seem unsettling, but in the scale of the universe, such balances are common. Mercury, for instance, is caught in a 3-to-2 rhythm. It spins 3 times for every 2 orbits around the Sun. Venus turns backward, so slowly that one of its days lasts longer than its year. Jupiter spins the fastest, once every 10 hours, its speed giving rise to storms larger than our entire planet. And yet, for all their variety, these worlds are bound by the same ancient rule. Once set in motion, they keep turning until something stops them. When you think of it that way, rotation is not just a mechanical act, it's a kind of memory. Each planet carries the story of its birth in its spin. The Earth's slow, steady turning is a remnant of the swirling disk of dust and gas that once circled the newborn sun. Every rotation today is an echo of that first great whirl, the moment when gravity gathered chaos into order and light found a rhythm. And perhaps, on a smaller scale, we echo it too. The pulse in your wrist, the rhythm of your breath, the gentle rise and fall of sleep, they're all forms of turning, cycles within cycles. You are, in every sense, a product of motion, a tiny continuation of the Earth's spin. If you listen closely, you might almost hear it, the whisper of rotation beneath the quiet of night. It doesn't hum like a machine or tick like a clock. It's the faintest kind of music, a balance so perfect it becomes invisible. Every sunrise, every moonrise, every heartbeat is tuned to it. and as you rest, the world carries you onward, gently spinning toward morning. The earth keeps turning beneath your dreams, as it always has and always will. And if we follow this rhythm a little further, it leads us beyond our world, back through the vast darkness, to the moment when motion itself began. The first spin of the universe, when nothing yet existed but the desire to move. If we follow the thread of motion backward, past the turning Earth and the orbits of planets, past the glowing arms of galaxies, we eventually reach a moment where there was no motion at all, or at least that's what we once thought. Imagine a time before time, a place before place, when the universe was smaller than a grain of dust. Nothing had form or direction. There was no up or down, no light or darkness, no space to turn within. And yet, somehow, from that stillness came movement. Somewhere in that first breath of existence, the universe began to spin. Scientists call this the Planck era, the first unimaginably brief moment after the Big Bang. To describe its length, they use numbers that don't fit easily into speech, about 10 to the minus 43 seconds. That's a decimal point followed by 42 zeros before the 1. A sliver of time so small it almost doesn't exist at all. And yet within that flicker, all the rules that would shape the cosmos were born. Matter, energy, space and time unfolded together, each influencing the other like dancers learning their first steps. The universe may have begun not as a still explosion, but as a swirl, a turning wave of energy. Even in complete emptiness, physics tells us that space is never truly calm. Tiny fluctuations appear and vanish, brief jitters of energy known as quantum fluctuations. You can think of them as the heartbeat of nothingness itself, little sparks that flicker in the vacuum. When the universe was young, those microscopic jitters were stretched and amplified as space expanded in a period scientists call inflation, a moment when the universe grew faster than the speed of light. To say faster than light doesn't mean the laws were broken. It means the fabric of space itself was stretching, carrying those tiny ripples with it. Imagine painting dots on a balloon and watching them move apart as you inflate it. Inflation turned those quantum ripples into enormous waves, regions where matter was just slightly denser or lighter than its surroundings. As space expanded, those ripples became the seeds of galaxies, stars, and everything that would ever spin. Astronomers can still see traces of this ancient pattern in the sky today. It's called the cosmic microwave background, the faint afterglow of the Big Bang, still whispering across space more than 13 billion years later. Satellites like NASA's WMAP and the European Space Agency's Planck Observatory have mapped it in exquisite detail. What they found surprised even the most careful cosmologists. The glow isn't perfectly uniform, it contains faint swirling patterns, tiny differences in temperature, 1 part in 100,000. Some researchers noticed that those patterns seem to line up along a particular axis, as though the universe itself might have a preferred direction of rotation. They called this strange alignment the axis of evil, not for any sinister reason, but because it challenged the comforting idea that the universe has no center or orientation. If that alignment is real, it could mean that our cosmos once spun as a whole, carrying everything inside it along for the ride. Others suggest it might just be an artifact, a coincidence in the data, but the question remains open. Even now, astronomers continue to test whether a subtle global twist still echoes through the background light of creation. If that early rotation did exist, it might have helped define the universe's structure. The swirling motions we see in galaxies could be faint descendants of that first cosmic spin. Just as a skater turns faster by drawing in her arms, collapsing matter in the early universe would have spun more quickly as it gathered together under gravity. No motion appears from nowhere, it must be inherited. The universe didn't need to learn how to turn, it was born turning. In 2011, researchers from the Harvard Smithsonian Center for Astrophysics analysed more than 15,000 spiral galaxies. They found a tiny imbalance in their directions of rotation. Slightly more spirals turned one way than the other. That asymmetry might trace back to the early universe's first twist, a cosmic preference written into its structure. Later, in 2020, astrophysicist Leo Shamir examined 200,000 galaxies using data from the Sloan Digital Sky Survey. He found a similar pattern, a quiet bias in the way galaxies spin across the sky, as if the universe still remembered which way it first turned. This doesn't mean the cosmos is whirling like a top through empty space. It's subtler than that. If space itself once rotated, if it had even the faintest twist during its expansion, then that rotation would be woven into the geometry of everything. It would shape how galaxies formed, how matter clumped, even how time itself flows. A turn so vast and gentle that we can't feel it, but one that guides the motion of billions of worlds. The cause of that first twist might lie in something even smaller than atoms. When the universe was still a sea of energy, the fundamental forces we know today, gravity, electromagnetism, and the nuclear forces, were not separate. They were one, joined in a perfect symmetry. But as the universe cooled, that symmetry broke. The forces split apart, and with that breaking came the first distinctions: direction, charge, spin. It was imperfection that gave rise to motion. If the universe had remained perfectly balanced, nothing would ever have moved. In the same way that a pencil standing perfectly upright must eventually fall one way or another, the universe's perfect stillness was unstable. A single quantum nudge was enough to make it turn. Astronomers now search for the fingerprints of that first motion in the polarization of ancient light. The faint curls and patterns, known as B-modes, in the cosmic background may be the fossil record of the universe's earliest rotation. Detecting them is like trying to hear the echo of a whisper across billions of years, but every new telescope from the South Pole to space itself listens a little closer. Even the invisible parts of the cosmos may carry that legacy. Computer simulations from NASA's Jet Propulsion Laboratory show that dark matter halos, the unseen scaffolds that cradle galaxies, twist and rotate over billions of years. These invisible whirlpools guide the stars within them, keeping their shapes stable and their motions graceful. It's as if the early universe wound them up and set them turning, then left them to spin in silence. And perhaps that is the most remarkable truth of all. The universe doesn't need a hand to keep turning. Once the first motion began, the laws of physics did the rest. Angular momentum, the tendency for rotation to continue unless disturbed, is one of the universe's simplest and most faithful rules. Nothing spins from nothing. Motion must come from motion. That quiet principle links everything from electrons to galaxies, from the swirl of your breath to the turning of the heavens. When you look at the night sky, you're not seeing chaos. You're seeing the preserved memory of a single ancient gesture, the first twist of existence. Every orbit, every revolution, every spin is a continuation of that beginning. The stars overhead are not just shining, they're turning, carrying the memory of that first motion forward. Take a moment to feel the weight of that thought. The atoms in your hands, the particles in your breath are still spinning with that same primordial momentum. The universe has been turning for nearly 14 billion years, and you are part of that motion, carried within it like a note inside a song that never truly ends. And as our quiet exploration continues, we turn our gaze from that first cosmic swirl toward its consequences, how this eternal spin, once set in motion, made it possible for worlds like ours to exist at all, and for life to find its place in the rhythm of the stars. Every movement has a memory. When you toss a pebble into a pond, the ripples carry its motion outward long after the stone has sunk. The universe works the same way. The first twist that began time itself has never faded. It stretches through galaxies, through stars, through the quiet spin of the planet beneath your feet. Even now, billions of years after the first light broke through the darkness, everything still turns with the echo of that ancient motion. If you could travel back to the earliest days of the cosmos, you would see that rotation written everywhere, though not in ways we might expect. There were no suns, no planets, no stars yet, only vast clouds of hydrogen and helium slowly gathering under the pull of gravity. But even those clouds carried a faint spin, inherited from the unevenness of the Big Bang. Where one region of space was slightly denser than another, gravity pulled matter together a little faster, and as it collapsed, it began to turn. This is one of the most beautiful and consistent rules in physics. When something falls inward, it spins faster. A skater drawing her arms in, a planet forming from dust, even a collapsing star, they all follow the same choreography. Scientists call it the conservation of angular momentum, but you don't need the equation to feel its meaning. It's the law that says motion cannot be lost, only changed in form. The early universe was like a grand ballet, where every contraction led to a spin, and every spin became the seed of structure. Stars were born from this cosmic swirling. When enough gas and dust gathered together, gravity squeezed them tighter and tighter until their cores began to burn. Each young star spun like a glowing wheel, surrounded by a disk of leftover matter, the beginnings of planets, moons, and asteroids. You can still see this pattern in images from the James Webb Space Telescope. Delicate, flat rings of dust around infant stars, each one a miniature echo of the universe's first turn. The rotation of those early disks set the rhythm for everything that would follow. The length of planetary days, the tilt of their axes, even the direction their moons would orbit. Our own solar system keeps that memory. The sun, planets, and most of their moons all turn in the same direction, counterclockwise when viewed from above the North Pole of the ecliptic. It's as if they were all spun from a single invisible hand. Even comets and asteroids, scattered and irregular, carry remnants of that shared rotation. The faint spin of the early universe still echoes through every orbit, every tide, every sunrise. But the memory doesn't stop at the level of planets. Entire galaxies too bear its mark. Spiral galaxies like our Milky Way rotate as if stirred by some enormous unseen spoon. At their centres, dense clusters of stars whirl around invisible hearts, supermassive black holes. These black holes spin as well, some nearly at the speed of light. The energy of their rotation twists magnetic fields, flinging streams of matter outward in jets that stretch for thousands of light years. It's the same pattern, repeated again and again. Motion preserved, reimagined, reborn. Even the most mysterious substance in the cosmos, dark matter, seems to carry the same rhythm. Though we cannot see it, computer models show that dark matter forms giant halos around galaxies, gently spinning over billions of years. Without those invisible halos, galaxies like ours would not hold together. Their stars would fly off into the void. Dark matter is the silent keeper of the universe's balance, its unseen spin stabilizing everything we can see. It's humbling to realize that all of this, the movement of oceans, the orbit of moons, the turning of galaxies, arose from tiny imperfections in the universe's earliest moments. A small unevenness, a whisper of asymmetry, was enough to give everything a direction. In a perfectly balanced universe, nothing could ever move. But ours is not perfect, and that imperfection is the reason we exist. The faint spin that began it all still shapes the structure of every atom and every star. Physicists sometimes say that the universe has frozen in its original conditions. That means the laws and patterns that appeared in those first moments became part of the framework of everything that came after. You can think of it like a potter's thumbprint pressed into soft clay. The mark remains even after the clay hardens. Every galaxy that turns today is in some sense following that first pattern. Every atom that spins, every electron that carries its tiny magnetic field remembers the direction of that original motion. This memory is not just a metaphor, it's measurable. In the light from distant galaxies, astronomers can see subtle differences in colour, one side slightly redder, the other slightly bluer. This happens because of motion. The side spinning away stretches its light, while the side coming toward us compresses it. Those red and blue fingerprints allow scientists to measure how fast galaxies rotate, and to trace how rotation has evolved across cosmic time. Even light itself becomes part of the record, carrying the memory of every turn it encounters. And so, across billions of years, the universe has been writing its history in spirals and circles. The spiral arms of galaxies, the orbits of planets, even the whirls in a shell or the shape of a hurricane, all of them follow the same geometry. It's a language older than stars, a pattern that repeats wherever energy finds balance. We are surrounded by these echoes of the first spin, though we rarely recognize them. They appear in water draining from a sink, in the twist of DNA, in the flow of air around your breath. To understand this is to see motion not as chaos, but as memory. The universe remembers everything it has ever done, not in words, but in the way it moves. Gravity, light, and spin are its handwriting. Every time something turns, it's repeating a line from an ancient script, a sentence that began with the first motion of all. Take a moment to imagine the scale of that memory. The atoms in your body, spinning quietly in their orbits, are carrying the same momentum that once shaped galaxies. The calcium in your bones was forged inside a rotating star. The iron in your blood was spun outward from a supernova, thrown into space by the violent twist of a dying sun. Every element, every molecule, every heartbeat carries the same inheritance. You are, in a very real way, made from the memory of motion, and yet that memory is not finished. The universe continues to turn, to spin, to flow. The same forces that began time still shape it, one rotation at a time. When you look at the night sky, you're seeing billions of fragments of that first spin still in motion. Each star is a ripple from the same stone thrown into the pond of creation. From here, the story opens into something even more intimate. Because if the first spin built the stage for the cosmos, the next turns of motion began to build the conditions for life itself, the slow, rhythmic rotation of worlds that breathe, protect, and remember. If we follow the story of spin a little closer to home, it leads us to a small blue world wrapped in clouds, our Earth turning gently beneath the sun. Every sunrise, every wave, every gust of wind is born from that motion. The planet's rotation is not a background detail of physics. It is the hidden rhythm that breathes life into everything you know. Imagine Earth as it might have been long ago, fresh from its fiery beginnings, molten, chaotic, glowing with heat. In that restless young world, the first great spin was already underway, a memory from the swirling disk of dust that had formed our solar system. When that disk collapsed under gravity, its material began to turn faster, like a skater pulling in her arms. Out of that motion came the sun at the centre, and around it, a family of spinning worlds, each carrying its own measure of that ancient momentum. Earth was one of them, and it has never stopped turning. At the equator, the surface of our planet races eastward at more than 1,000 miles per hour. If you could see the air move with it, you would notice that it doesn't rush past or pull away. It turns along with the ground, carried by the same invisible grip. From space, Earth's rotation looks serene, clouds stretching into spirals, oceans reflecting sunlight as they drift beneath the shadow line of the night. It seems calm, but that motion is everything. Because the Earth spins, we have day and night, the simplest and most essential rhythm of life. Without it, One half of the planet would bake endlessly under the sun while the other would freeze in permanent darkness. Instead, the planet's gentle turning spreads light and warmth across the surface, giving every creature its share of dawn and dusk. That constant sharing is what allows the atmosphere to breathe. Warm air rises, cool air sinks, and the planet's rotation curves those motions into vast patterns. Winds sweep across the oceans, forming loops and spirals. The invisible handwriting of the Coriolis effect. You can see its mark in satellite images. Great storms curling like brushstrokes, currents tracing slow ribbons of motion through the sea. Deep below, the spin continues. Far beneath the crust, the Earth's iron heart turns in molten layers. That rotation generates a magnetic field, a shield that protects everything alive from the sun's harsh radiation. Without it, charged particles would strip away the air and water just as they did on Mars. On that quiet red planet, the molten core cooled long ago, and the magnetic field faded. Its sky lost its protection, its seas dried away. But here, the molten motion persists, spinning like a great dynamo. The auroras you sometimes see near the poles, curtains of green and violet light, are the visible glow of that protection, born from the meeting of solar wind and magnetic shield. Our spin also keeps the oceans in motion. The moon's gravity pulls at the water, and Earth's rotation transforms that pull into tides, a slow breathing of the sea. Each wave that rises along the shore is part of that steady dialogue between Earth and Moon. The two have been locked in this dance for more than 4 billion years. Long ago, our days were only 6 hours long. The Moon's gravitational pull has been quietly slowing Earth's rotation ever since, stretching the day by about 1.5 thousandths of a second every century. That's so gentle you'll never notice it, yet it's enough to lengthen our days from the brief twilights of early Earth to the 24-hour cycle that now rules our lives. This balance between rotation and tide also keeps the planet's tilt steady, about 23.5 degrees. That tilt gives us seasons, and the Moon's constant pull prevents it from wobbling too far. If our axis ever swayed wildly, climates would swing from burning heat to freezing cold. Instead, the Earth keeps its calm, moving like a top that never quite tips over. In this steadiness, life found its chance. Every creature on Earth, from the simplest bacteria to you sitting here now, carries within it a sense of the planet's spin. Scientists call it the circadian rhythm, an inner clock that ticks in harmony with the turning of the world. Even without sunlight, cells continue to follow this pattern, opening and closing, resting and waking as though they can still feel the pull of the sun through the planet's rotation. It's written in our DNA, in the way our hormones rise and fall, in how we sleep and dream. You could say that our bodies are tuned to the same rhythm that moves the oceans and winds, and when you look beyond Earth, you see how precious this rhythm is. On Jupiter, the day lasts less than 10 hours, so fast that storms rage in endless bands, including the Great Red Spot, a hurricane larger than Earth itself that has spun for centuries. On Venus, the opposite happens. One full rotation takes 243 Earth days, and it turns backward compared to the other planets. Its slow, reversed spin means its surface is scorched by permanent daylight on one side, frozen in endless night on the other, its atmosphere locked in a choking heat. Mars spins once every 24.5 hours, almost like ours, but its heart has gone still, and its air is thin, its world half asleep. Only Earth seems to have found the perfect tempo. Not too fast, not too slow. A rotation that keeps it breathing gently, alive. When astronomers look at distant exoplanets, they measure how quickly those worlds turn. A planet that spins too slowly becomes a desert of extremes. One that spins too fast may be battered by storms too fierce for life to form. But somewhere in between, in that delicate balance, lies a chance for stability, for oceans, for weather, for memory. Rotation, it turns out, is one of the quiet conditions for life. Without it, there might be light but no warmth, gravity but no balance, motion but no rhythm. The planet's spin has never stopped shaping who we are. It guides the path of clouds, the migrations of birds, the blooming of flowers, even the tides of sleep and thought. Every heartbeat you feel, every breath you take, belongs to a chain of rotations stretching back to the universe's first motion. The Earth turns, and because it turns, it breathes, through wind, through water, through you. If you could step outside the planet and look back, you would see it turning beneath you, blue oceans glinting, white clouds tracing spirals, continents moving through soft shadow. It's a view astronauts describe as both humbling and alive, the sight of a world that never stops, a single, breathing sphere adrift in the dark. That rotation, that quiet heartbeat, is what holds everything together. Take a moment to imagine it now, the air, the oceans, the molten heart, all moving together. The sound of that spin is silence, and the rhythm of that silence is life itself. As we drift further into the story, let's follow that rotation outward to see how the same turning that gives life to a planet can begin to bend something even stranger, the flow of time itself. Every living thing on Earth keeps time, but not by numbers or watches. Deep within every cell there's a rhythm that hums quietly, turning with the same grace as the planet itself. It is not a clock that ticks or chimes, but one that breathes, a rhythm shaped by sunlight, darkness, and the endless spin of the world. From the moment the first organisms appeared in the oceans billions of years ago, they learned to follow the turning Earth. Even without eyes or reason, life could feel the shift between day and night, the rise and fall of light. It is as though the planet whispered its rotation into the pulse of every living thing. Imagine a tiny cell floating in warm water, long before animals or plants existed. Within that cell, certain molecules activated when the light grew strong and rested when the light faded. That simple pattern, wake and rest, rise and fall, became the seed of something extraordinary, the biological clock. Over time, it evolved into what scientists now call the circadian rhythm, from a phrase meaning around a day. It's an ancient memory written into the chemistry of life, and even today it's still ticking inside you. Inside your brain, near the crossing of the optic nerves, lies a cluster of about 20,000 neurons called the suprachiasmatic nucleus, the master clock of your body. It listens to light, measuring the difference between dawn and dusk, and it keeps every cell in tune. Each of your organs, your heart, your liver, your skin, has its own clock, but all of them follow that conductor in your head, like instruments in an orchestra guided by the same baton. When sunlight hits your eyes in the morning, it resets the rhythm, telling your body it's time to begin again. This quiet coordination governs nearly everything about you. Your temperature rises and falls with the day. Your alertness peaks in the late morning, your strength in the afternoon, your dreams just before dawn. Even your heartbeat changes tempo as the Earth turns. And when that rhythm drifts, when artificial light stretches your nights too long, or when you cross time zones faster than your biology can follow, you feel it immediately. Jet lag, sleeplessness, mood swings. They're all signs that your inner rotation has fallen out of sync with the planets. But it's not only humans. Flowers know the spin of the Earth too. Some open only in daylight and close at dusk, even when they're kept in constant darkness in a lab. The rhythm is built into their cells. Birds wake before sunrise because their inner clocks already anticipate the dawn. Coral reefs release their eggs in perfect unison on certain nights each year, guided not by chance but by the steady relationship between moonlight, tides, and rotation. Even bacteria in the deep sea where sunlight never reaches follow subtle patterns of chemical energy tied to the same 24-hour cycle. The whole planet breathes together, synchronized through time and motion. That connection between rotation and life isn't just poetic, it's physical. The turning Earth divides the planet into moving belts of light and shadow. Those boundaries change the chemistry of the air and water, setting up temperature differences that drive ocean currents and winds. These in turn mix nutrients in the sea and bring rain to the land. Without that constant stirring, life could never have spread so widely. The planet's spin is the unseen engine of balance, blending hot and cold, day and night, energy and rest. Even the moon's slow pull shapes our sense of time. When the Earth was young, its day was only 6 hours long. The moon, forming from the debris of a colossal collision, began to pull on the oceans, creating tides. Those tides acted like brakes, gently slowing the Earth's spin over billions of years. Every century, the day grows longer by about 1.5 thousandths of a second. It's so small you'd never feel it, but the change has shaped life in profound ways. Many creatures still follow the rhythm of the tides: crabs, oysters, seaweed, rising and falling not to the clock of the day, but to the heartbeat of the moon. When astronomers study other worlds, they often wonder if their rotations are steady enough to support such harmony. A planet that spins too slowly may leave one side scorched and the other frozen, making life nearly impossible. One that spins too quickly might face violent storms that tear its atmosphere apart. Earth has found a rare balance. Its 24-hour rhythm creates a middle ground, a planet that wakes and rests, that knows warmth and coolness, that keeps time softly enough for life to grow. Think of how many layers of rhythm you live within. The Earth turns once each day. It orbits the Sun once each year. The Moon circles Earth every 29 days. Your heart beats every second. Your lungs rise and fall every few moments, and your thoughts ripple with electrical waves that oscillate dozens of times each second. From the cosmic to the microscopic, everything that lives is spinning, pulsing, or oscillating. The scales are different, but the music is the same. That may be why sleep feels so natural. It's our way of matching the planet's slower rhythm after sunset. When you drift off, your body temperature falls, your metabolism quiets, your thoughts begin to move in wider, slower circles. You enter a pattern of waves, deep sleep, dreaming, waking, and back again, each lasting about 90 minutes, roughly the same as the time it takes the International Space Station to orbit the Earth. It's as though your brain, without realizing it, follows the same cosmic rhythm that governs everything else. In this way, time isn't something that passes outside of you, it's something that moves through you. You measure it not by clocks, but by cycles, by the repetition of motion and stillness. The Earth's spin is the planet's heartbeat, and your heartbeat is its echo. The rhythm of life is not separate from the rhythm of the world. It's one continuous pattern. You're not just living in time. You're part of the mechanism that makes time real. When you step outside at night and feel the cool air on your face, you're standing in the flow of that same rhythm. The stars drift slowly overhead, not because they move, but because you do. Every second the world turns you eastward, quietly and constantly. It is a motion too vast to feel, yet intimate enough to live inside your breath. If you let your imagination drift for a moment, you might picture all of this: the turning planet, the breathing oceans, the pulsing hearts, the shifting tides, as one great organism. Not a machine, not a clock, but a living being whose body is made of motion. Its pulse is the Earth's rotation. Its breath is the change of day and night. And you are one small cell within it, turning gently with everything else. As our quiet exploration continues, we'll begin to follow this rhythm beyond the boundaries of biology, into the deeper layers of physics, into the strange places where rotation bends more than light and darkness, where it begins to shape time itself. Einstein once said that imagination is more important than knowledge. To understand how motion can bend time, it helps to imagine, not with equations or chalkboards, but with pictures you can feel. So let's begin with something simple. Picture a still lake on a quiet morning. The surface is smooth, calm, mirror-like. Now, take a single pebble and drop it in. Ripples spread outward, gentle rings that carry motion across the water. Einstein saw the universe much like that lake. Space and time were not two separate things, but one continuous fabric. Space-time, stretching everywhere, invisible yet real. Every planet, every star, every atom is like a pebble resting on that surface, and when something moves, especially when it spins, it stirs the fabric itself, creating curves and flows. Space bends around mass. Time flows differently near motion. The universe, he realized, isn't just a stage where events happen. It's a living, flexible medium, shaped by everything that moves within it. Now imagine that the Earth, our own spinning planet, is slowly stirring this cosmic lake. As it turns, it drags the space around it ever so slightly into a swirl. The effect is tiny, so gentle that you'd never feel it, but it's there. Scientists call it frame dragging, a name that sounds mechanical but is really more like poetry. The idea that the Earth's rotation twists the flow of time around it. Einstein predicted this over 100 years ago, but it took nearly a century for us to test it. In 2004, NASA launched a satellite called Gravity Probe B, carrying 4 perfectly round gyroscopes, so smooth that if you enlarged one to the size of the Earth, the tallest bump would be less than the thickness of a single leaf. These gyroscopes orbited the planet for a year, measuring the tiny changes in direction caused by Earth's spin. When the data came in, it matched Einstein's prediction. Space and time were being pulled along with the planet, just as he had imagined. You can picture it like honey swirling around a spoon. The Earth is the spoon, space-time is the honey, and the motion spreads out invisibly through the surrounding space. Every rotation, no matter how small, stirs the universe's geometry. When a massive body spins, the very flow of time curves around it, like currents in a slow-moving river. You might think this is only true near massive things, black holes, neutron stars, but even here, on our modest blue planet, time itself feels the touch of rotation. At the equator, where the Earth spins fastest, time flows just a fraction more slowly than at the poles. The difference is minuscule, a few nanoseconds each day, far too small to sense, but it's there, woven into your seconds, your heartbeat, your breath. Every clock on Earth is slightly unique because of this. A watch at sea level ticks more slowly than one in the mountains, where gravity's pull is weaker. A satellite orbiting above you experiences time differently still, running faster because it feels less of the Earth's gravity, but slower because of its own speed. Engineers who build GPS systems must constantly correct for these differences, or our navigation would drift miles off course every day. When your phone tells you where you are, it's quietly adjusting for relativity, a whisper from Einstein's lake, keeping you in step with the flow of space-time. The strange thing about all this is how natural it really is. You've seen the effects of curved motion every day. When you stir a cup of tea, you watch the liquid spin faster near the centre and slower at the edges. The same happens with planets orbiting the sun. The closer they are to its warmth, the faster they move. The same again with stars in galaxies, turning like glowing spirals in a cosmic teacup. Nature loves curves. It loves to swirl, to bend, to spiral. Straight lines, it seems, are rare luxuries. Einstein's insight wasn't that gravity pulls, but that it flows. When you drop an apple, it doesn't fall because the Earth tugs at it. It falls because space-time is curved, and the apple is following the simplest possible path through that curve. When you're standing still, you're actually moving through time, tracing a line through that same invisible landscape. The faster you move through space, the slower you move through time. And when you spin, you bend that flow just slightly, shaping time's texture as you go. It's strange, isn't it, to realise that motion and time are so deeply entwined? When you turn, the universe feels it. When the Earth spins, time itself feels it. You don't sense the change, but it's happening quietly, everywhere, all the time. The clocks on satellites, the orbit of the moon, even the way light curves around mountains, all of it is part of one great conversation between motion and time. Einstein used to describe the universe as a blend of geometry and emotion. That might sound sentimental for a physicist, but in a way he was right. The equations he wrote were his way of feeling the shape of reality, of describing in numbers what we can only sense as wonder. But you don't need equations to understand it. You only need to imagine that calm lake, stirred by the turning of worlds. The Earth's frame-dragging effect is incredibly small. The swirl of space-time around it moves only a few billionths of a degree per year. But if even our little planet can twist time, imagine what happens around stars, around pulsars spinning hundreds of times each second, or black holes rotating at nearly the speed of light. There, the flow of time doesn't just bend, it spirals. If you were to approach one of those immense objects, you'd see space itself beginning to twist. Light would bend in graceful arcs, trapped in whirlpools of gravity. Time would slow as you drew nearer, stretched like taffy around the spinning core. Inside that curve, motion becomes meaning. Every rotation deepens the well of time, shaping the way the universe evolves. Perhaps that's the quiet truth hidden behind all this mathematics. Rotation is not just motion through time, but the way time learns to move through itself. The same spin that turns a planet or stirs a cup of tea is also what sculpts the tempo of existence. Motion doesn't just exist within time, it weaves time together. Take a slow breath. You're sitting inside that fabric right now, floating on its gentle currents. The air around you, the ground beneath you, even the second ticking by, everything is part of a silent, rotating ocean of space-time. And as we drift further into the story, the path now carries us toward the darkest places in that ocean, where rotation becomes so fierce that light, space, and time are pulled into one endless spiral. There, the universe shows us its most mysterious form of motion, the spinning heart of a black hole. Imagine watching a whirlpool form on the surface of a lake. It starts as a small swirl, then deepens, pulling water inward faster and faster until it disappears into its own centre. Now imagine that same idea, stretched across the vastness of space, a whirlpool so deep that not even light can escape. That is a black hole, the universe's most silent dancer, a body made entirely of gravity and spin. Black holes are not holes at all, of course. They are regions where matter has been crushed so tightly that space itself curves inward. The more massive and the faster they spin, the more they twist everything around them. Space, time, light, even the rhythm of cause and effect. What began as simple gravity becomes something stranger. Rotation so intense that the fabric of reality folds back on itself. Some black holes are born from dying stars. When a star many times larger than our sun exhausts its fuel, its own gravity takes over, collapsing it inward. If the collapse is complete enough, nothing can stop it. The star's mass gathers into an unimaginably small point, called a singularity, surrounded by an invisible surface known as the event horizon, the point beyond which escape is impossible. But not all black holes are the same. Some barely spin at all, quiet and still. Others whirl at astonishing speeds, dragging entire regions of space into motion. The fastest spinning black holes we've found rotate almost at the speed of the light. If you could stand safely nearby, though of course you never could, you'd see space itself spiraling like water in a drain. This is what physicists call a Kerr black hole, named after the mathematician who described its geometry. Inside its influence lies a strange zone called the ergosphere, where space and time twist so violently that everything, even light, must rotate with it. If you tried to hover there, you would be forced to move, carried along like a leaf in a hurricane. To picture this, imagine stirring honey with a spoon again, as we did when talking about Earth's frame dragging effect. The black hole is the spoon, but this time the honey is being stirred at nearly the speed of light. The flow is so powerful that space itself behaves like a thick, rotating fluid. Every particle, every photon caught near the hole must follow the spin. Time slows dramatically. To an outside observer, it almost stops. Astronomers have seen signs of these spinning monsters. In 2019, the Event Horizon Telescope captured the first direct image of a black hole. Its glowing ring of light surrounding a dark centre, the shadow of space itself being swallowed. That black hole, in the galaxy M87, is 6.5 billion times the mass of our Sun. It spins so rapidly that the material around it, dust, gas, entire stars, forms a disk moving at a significant fraction of the speed of light. The light from that disk bends and folds as it escapes, creating the glowing halo we see. In the middle, where no light can return, lies the purest silence in the universe. Closer to home, at the centre of our Milky Way, another black hole waits, Sagittarius A. It's smaller, only about 4 million times the Sun's mass, but it too spins, gently stirring the stars and gas near it. The Event Horizon Telescope captured its image as well, showing the same familiar shadow, proving that these objects follow one rule throughout the cosmos. Rotation is their language. Even in darkness, they turn. The strange thing about black holes is that their spin never fades. As they form, they inherit angular momentum from the stars that collapse to create them, and once that spin begins, nothing can stop it. There's no surface to slow them down, no air, no friction, nothing to take the motion away. A black hole can keep spinning for trillions upon trillions of years, long after the stars around it have died. The fastest known black holes are almost at the cosmic limit. One, known as GRS 1915 Plis Science-Fiction, whirls at more than 98% of the speed of light. Its gravity bends time so severely that if you orbited close enough, every second you experience would stretch into minutes or hours for someone far away. The math behind that sounds cold on paper, but in truth, it's like poetry. The closer you move toward a black hole, the slower your story unfolds. Time itself becomes reluctant to leave. And yet black holes aren't just destroyers, their spin can also create. When gas spirals into them, magnetic fields twist and tighten, launching jets of matter and light that shoot out into space. These jets can travel thousands of light years, seeding galaxies with energy and particles. In that sense, a black hole is both an end and a beginning, where the death of one star helps shape the birth of many more. Even the most silent objects in the cosmos participate in the great rhythm of creation. We don't have to look to the edges of galaxies to see relativity at work. Every GPS satellite orbiting above Earth has to account for these same effects of motion and gravity, though on a far smaller scale. Without those adjustments, our maps would drift by several miles each day. It's astonishing to think that the same laws guiding the spin of black holes are quietly helping you find the nearest coffee shop. The universe has a sense of symmetry, even in the smallest conveniences. If we could watch time flow around a spinning black hole, it would look like a whirlpool made of hours and seconds. Closer to the centre, time thickens. Farther out, it stretches thin. For an observer falling inward, everything outside would appear to accelerate, the entire universe rushing toward its end. But to someone far away, the falling traveller would seem frozen, forever approaching the edge but never crossing it. Both views are true, because time itself is not a single stream. It's as curved and multifaceted as the space it belongs to. There is a quiet elegance in this symmetry. The same spin that keeps the Earth alive also governs the behaviour of these cosmic giants. Rotation, it seems, is the universe's handwriting, used in every scale from atoms to galaxies. It shapes not only space but the passage of time itself. Around black holes, this becomes literal. Motion changes time's flow, reshaping what before and after even mean. Perhaps that's the ultimate message hidden in their darkness. Rotation doesn't just move through time, it writes time. Each turn of a star, each spin of a particle, each orbit of a world is another sentence in the universe's story, carved into the geometry of reality. If you listen closely enough, you might almost hear it, the slow, spiralling hum of existence itself. It's not sound as we know it, but a vibration that has no need of air. The rhythm of space-time rotating forever, writing its own continuity. And as our gentle journey continues, we'll leave these immense cosmic whirlpools behind and turn our gaze inward again, to the smallest scale, where spin becomes the keeper of time itself, and where a single atom can hold the heartbeat of the universe. If you could shrink yourself down until the universe faded and only an atom remained, you would find a world that moves not through orbits and revolutions, but through vibration. A world where motion becomes rhythm and rhythm becomes time. The tiniest things in existence don't tick or spin the way a planet does, but they do something just as profound. They oscillate, they pulse, they dance between states of energy. And it's through that microscopic dance that we, in our vast, slow world, measure the passing of a second. In the quiet laboratories where atomic clocks live, time doesn't flow, it hums. Each clock keeps track of moments using the movement of atoms, most famously the element cesium. In the 1960s, scientists redefined the very idea of a second based on cesium's rhythm. Inside an atomic clock, cesium atoms are gently heated and guided through a beam. When microwaves of just the right energy touch them, the atoms switch between two energy states, like tiny pendulums changing direction. Each complete switch, from one state to another and back again, is a beat of time. Count about 9 billion of those transitions. Precisely 9,192,631,770, and you have 1 second. That number sounds impossibly precise, but it's less about counting and more about listening. These atoms vibrate at a frequency so stable that if you let the clock run for millions of years, it would lose less than a single second. The light pulses that mark these transitions are unimaginably fast, but their rhythm is eternal, steady, unwavering, and almost musical. Each atomic clock is like a tiny violin playing the same perfect note, resonating with the universe itself. When Einstein said that time is relative, he meant that no clock anywhere in the universe ticks exactly like another. Gravity, motion, and rotation all stretch or compress time ever so slightly. Atomic clocks allow us to see this truth with exquisite clarity. At sea level, where gravity is strongest, a cesium clock ticks infinitesimally slower than an identical clock placed high in the mountains. Move that same clock into orbit, where Earth's gravity weakens and it speeds up. The difference is only billionths of a second per day, but it's enough to make a measurable change and to remind us that time is not something the universe gives us. It's something we create through motion. Every GPS satellite orbiting above Earth carries atomic clocks, quietly keeping count of those cesium beats. Because time flows faster in orbit and slower on the ground, their clocks drift apart by about 38 millionths of a second every day. It doesn't sound like much, but if we ignored that drift, our maps would be off by miles. So engineers adjust the signals, bending human time to match the curve of space-time. When you navigate to a cafe, or when an aircraft lands safely, It's thanks to those atoms humming in perfect synchronization and to Einstein's understanding that even seconds are flexible things. The beauty of this is how it connects the smallest and the largest scales. The same physical rules that describe the spin of a black hole also describe the rhythm of an atom. Both are stories of motion, one told in thunder, the other in whispers. In a way, atomic clocks don't just measure time, they reveal the unity of motion itself. When you look at your watch or your phone, you're indirectly hearing the universe's heartbeat, translated through cesium's soft vibration. And though we call it atomic spin, that word doesn't mean these particles are spinning like tiny planets. Quantum spin is something subtler, a kind of built-in rotation that defines how particles behave in magnetic fields and how they interact with light. It has no surface, no direction you could see, yet it's as fundamental as charge or mass. It's what makes magnets work, what gives rise to the glow of atoms, what allows electrons to pair in the bonds that hold your body together. If the universe were music, spin would be the note that repeats in every octave. When you hold a compass, you're already touching the consequence of this invisible motion. The needle's direction is determined by the alignment of electrons within iron atoms, tiny quantum spins that prefer to face the same way. Multiply that pattern trillions upon trillions of times, and you get the magnetic field that guides travellers and migratory birds alike. Even at the smallest scales, rotation defines order, direction, and rhythm. Time itself seems to have chosen rotation as its instrument. The Earth spins once every 24 hours. The Moon circles Earth in about 29 days. The electrons in atoms move billions of times per second, and at every level, from the cosmic to the quantum, those rotations are linked by the same rule. Once motion begins, it continues. The conservation of angular momentum isn't a phrase to memorize, it's a promise the universe keeps, that no movement is ever wasted. There's something profoundly human about the desire to measure that movement. Thousands of years ago, people tracked the sun's shadow across the ground, counting the length of days. Later came pendulum clocks, their steady swings echoing the pull of gravity. Now, we've moved inside the atom, counting the rhythm of invisible vibrations. Each generation finds a smaller and steadier motion to define time, as if trying to hold the universe still for a moment, even knowing it never really can be. And so, the second, that simple, ordinary word, contains multitudes. It's not just a slice of duration, it's a reflection of motion itself. The heartbeat of cesium is tied to the turn of the Earth, which is tied to the orbit of the Moon, which is tied to the spin of galaxies. You live inside this great symphony, your own heart keeping time with the stars, though you may not feel it. When you pause and listen, really listen, you might realize that there's no such thing as absolute stillness. Even in your quietest moments, electrons hum in your atoms, cesium ticks in distant clocks, planets roll in their orbits. Time is nothing but motion observed, the universe's way of keeping rhythm with itself. Everything that moves measures, and everything that measures moves. From here, the story opens toward a broader principle, the quiet law that makes all of this possible. A rule so simple it could be mistaken for a whisper, yet so powerful that it shapes galaxies, stars, and the very dance of existence. The law that keeps every spin alive. Everything that spins, from a whirling galaxy to a drifting dust mote, follows the same quiet rule. A law that never raises its voice, never demands attention, and yet shapes the entire universe. It is the law of conservation of angular momentum, though that phrase sounds colder than what it truly is. In simpler words, it means that once motion begins, it keeps going unless something else interferes. It is the reason a spinning top steadies itself, the reason stars are born from collapsing clouds, and the reason the Earth keeps turning beneath your sleep. It is the universe's way of remembering. You can see this law at work in the smallest of gestures. Imagine a figure skater on ice. spinning gracefully with arms stretched wide. As she draws her arms close to her body, she turns faster, though she exerts no new effort. Nothing magical happens. She has simply gathered her motion inward, focusing her momentum. The total spin has not changed. It has only shifted its shape. The same rule applies to stars, to planets, to atoms, and to you. The tighter matter pulls itself together, the faster it turns. The wider it spreads, the slower it moves. Billions of years ago, the same thing happened on a cosmic scale. Clouds of gas drifting through space began to collapse under gravity, swirling into spirals as they condensed. The more they fell inward, the faster they spun, until the pressure and heat in their cores ignited nuclear fire. That's how stars were born, not from stillness, but from the deepening of motion. And when those stars later gathered dust and debris around them, the same law sculpted planets from the remnants, setting them spinning gently, endlessly. You are, Indy, a sense standing on a skater's arm, part of a movement that began long before there were words to describe it. This law of motion does not shout. It whispers through everything. You can feel it in the way a child's spinning toy keeps its balance, or in the way a gyroscope resists your attempt to tilt it. Hold one in your hand and twist it gently. You'll feel it push back, not violently, but firmly, as if insisting on its path. That resistance is the same principle that keeps satellites aligned in orbit and planets from tumbling chaotically through space. The universe seems to prefer balance, not through stillness, but through motion perfectly conserved. Angular momentum, that's the physicist's name for it, isn't stored in any one place. It's shared among all moving things. When you push a swing, the air, the ground, even your own body take part in the transaction. Nothing is lost. It merely changes hands. The same happens when a planet exchanges energy with its moon. As the moon's gravity tugs on Earth's oceans, the planet's rotation slows and the moon drifts slightly farther away. Motion passes like a note along an endless melody. Each verse remembers the one before. Even galaxies obey this quiet rule. When astronomers look at the great spirals scattered through space, they can see their stars orbiting faster near the center and slower near the edges, not because of machinery or friction, but because of balance. The total spin of a galaxy, like that of a skater, remains constant, even as its form changes across billions of years. The shapes we see, the elegant spirals, the curved arms glowing in starlight, are the visible expression of conservation, the universe's choreography of memory. You could think of this law as the heartbeat of stability. Without it, everything would unravel. Moons would drift away from their planets, planets from their stars, stars from their galaxies. The very shape of the cosmos depends on the fact that motion cannot simply vanish. It can be transferred, redirected, softened, but never erased. Every turn you see is the continuation of a turn that came before. What's remarkable is how this same rule links the cosmic and the personal. Every time you walk, dance, or toss a ball, you're participating in it. When you lean into a curve on a bicycle, you feel the gyroscopic steadiness that comes from spin. When a planet tilts and seasons appear, it's because that same invisible accounting of motion keeps everything in balance. The law that governs galaxies also governs the toss of your hand. And while this might sound mechanical, it isn't. It's deeply poetic. The universe doesn't hoard or waste motion. It simply keeps it moving, reshaping it, transforming it from one form to another. When a collapsing star becomes a black hole, its spin doesn't disappear. It concentrates, drawing everything around it into a tighter spiral. When a comet passes near a planet and changes direction, both bodies adjust. The comet gains a whisper of energy. The planet loses an equal whisper. It's as if the cosmos is composed of countless small courtesies, each movement returning what it borrowed. You can even find traces of this law in the lives of people. A dancer learns to move gracefully by distributing her weight, just as planets distribute theirs. A potter centers a lump of clay on a spinning wheel, shaping it with a steady hand. The same balance of inward pull and outward resistance that shapes worlds. When you see a leaf spiraling downward in autumn air, you're watching angular momentum at play, softened by friction but still faithful to its origin. Einstein once described physical laws as God's handwriting in the language of the universe. Whether or not you believe in a creator, the phrase captures something true. The conservation of spin is a kind of cosmic handwriting. Smooth, continuous, unbroken. From the smallest electron to the largest galaxy, every rotation is a line in that script. And because motion is never lost, the story never really ends. It just changes shape, looping back on itself in endless forms. The next time you watch a storm swirl or stir your cup of coffee, think of that. The spiral you see in the milk is the same geometry that sculpts hurricanes, the same that guides galaxies. It's the same mathematics that keeps the moon drifting steadily outward and that allows your body to stay upright as you walk. All of it obeys that one rule, the universe remembering its motion. So much of existence is about forgetting, light fading, stars dying, heat dispersing. But angular momentum is about remembrance. It's the proof that not everything fades entirely. Once set in motion, the universe keeps turning. Every spin you see, every sunrise, every storm, every heartbeat, is a continuation of that first impulse. Spin is the universe's gyroscope. It keeps balance without needing a hand. And if you listen closely, it almost seems alive. A motion so constant, so patient, that it becomes the silence beneath all other sounds. As we follow the thread of that silence, our story now turns towards something even deeper. The idea that imperfection, rather than order, may be the true origin of movement. Because for all this balance and lawfulness, the universe began not in symmetry, but in the breaking of it. When perfection cracked, motion was born. If the universe had remained perfect, nothing would have ever happened. No stars, no galaxies, no time, no breath. Perfection, for all its beauty, is a kind of stillness, a balance so flawless that it leaves no room for change. But the universe, it seems, was never meant to stay still. It cracked open almost as soon as it began, and in that tiny fracture, motion was born. Symmetry in physics means sameness. Imagine a mirror dividing a room in half. What happens on one side is reflected perfectly on the other. Before the universe took shape, everything existed in such balance. Matter and energy, light and darkness, all equal, all without preference. But symmetry is fragile. Even the smallest disturbance can shift it. Like a pencil standing perfectly on its tip, the early universe was balanced, and therefore unstable. One tiny nudge, one faint fluctuation, and it had to choose a direction. When that happened, everything changed. The universe didn't fall apart, it simply began to differentiate. Forces that were once united separated. Gravity went one way, electromagnetism another, and the nuclear forces split apart like threads unraveling from a single rope. Scientists call this event symmetry breaking, but it might be better to think of it as the universe taking its first breath. Perfect silence gave way to sound, stillness to motion, uniformity to individuality. At a fraction of a second after the Big Bang, a number so small it can only be spoken softly, the Higgs field appeared. You can imagine it as an invisible ocean filling all of space. Particles that passed through it suddenly began to feel resistance, as though swimming through honey instead of air. That resistance gave them mass, and with mass came the ability to move, to interact, to become. Before that moment, the universe was pure light, massless, frictionless, without memory. Afterward, it became capable of forming structure, of slowing down, of remembering its own motion. It's strange to think that the existence of weight, of solidity, of matter comes from this invisible field, but it does. Every atom in your body carries that faint resistance, the signature of the universe's first imperfection. When you pick up a stone or feel the heaviness of your own body, you're feeling the echo of that first asymmetry. Symmetry breaking isn't a failure, it's creativity. It's the way complexity is born. Think of a drop of warm air rising through cooler air, a smooth flow that suddenly curls into a swirl, a pattern, a storm. Or think of a painter's blank canvas, pure white, perfect, but lifeless. The first brushstroke is a break in symmetry, and from that break, the painting begins. The same happens in nature again and again. Snowflakes, leaves, coral reefs, galaxies. All of them begin with a symmetry that eventually breaks just enough to form shape and variation. Even your own heartbeat depends on it. The electrical signals that travel through your heart are not perfectly synchronized. They have a tiny asymmetry that keeps them oscillating. Perfect rhythm would be deathly still. Life depends on the imperfect pulse. When physicists talk about symmetry breaking, they often speak with awe, not frustration. It's as if the universe prefers to lean slightly toward difference, to explore imbalance. In doing so, it allows everything to exist. The very diversity of the cosmos, stars of every size, planets of every colour, atoms of every type, is the direct result of the universe's inability to remain perfectly the same everywhere. There's a simple experiment that captures this beautifully. If you balance a pencil exactly on its tip, in theory it could stay upright forever. But in practice, it never will. The tiniest vibration, a breath of air, the sound of your heartbeat, even the flicker of molecules moving in the air, will cause it to fall, and it can fall in any direction. The act of falling breaks the symmetry, but in doing so, it creates history. The pencil's direction of fall becomes a story, a preference, a difference. Before the fall, every direction was possible. After it, one direction becomes real. The universe did something similar, it tipped over, and the result was everything. That first fall set the tone for all of creation. From then on, motion and imperfection became companions. Balance still exists, but only as a tendency, not as a prison. The world oscillates between symmetry and asymmetry, between order and surprise. That oscillation gives rise to the richness we see around us. Even in the realm of particles, symmetry is constantly tested. Some particles behave almost exactly like their mirror images. Almost, but not quite. A subtle preference sneaks in, a left-handedness or right-handedness that breaks the mirror's illusion. These tiny deviations, too small for the eye to see, cascade upward to shape entire galaxies and perhaps even life itself. The very molecules that make you what you are, your DNA, your proteins, all twist in one direction, never the other. Somewhere, billions of years ago, the universe picked a side and everything followed. It's tempting to imagine that the universe was designed to favour imperfection, but it may be even more beautiful than that. Imperfection simply happens. It's the natural result of motion. Absolute balance cannot exist in a universe that moves, because motion itself is a choice, a preference for one path over another. So the act of moving, of spinning, of changing is already a kind of asymmetry. The moment the universe decided to turn, it could never again be perfectly still. When you look at yourself in the mirror, you're seeing symmetry. Two eyes, two hands, two halves that match. But look closer, and you'll notice that nothing aligns perfectly. One eye slightly higher, one shoulder slightly lower, one heartbeat faster than the next. That too is the mark of life. If your body were perfectly symmetrical, perfectly still, you would not be alive. Motion requires difference. Symmetry breaking, then, is not just a concept of physics, it's a philosophy of existence. The universe began to move because it allowed itself to be imperfect. It could have stayed a featureless ocean of light, but instead it stumbled into complexity. That stumble became time, gravity, matter, and thought. Every rotation that followed, every planet, every atom, every heart, traces back to that single, glorious imbalance. So the next time you see a crooked tree or a lopsided smile, remember that imperfection is not a flaw. It's a reflection of the universe's first decision, the choice to change. From that tiny deviation, everything began to spin. As we follow that spin further, the story now deepens into another kind of imbalance, one that determined why we exist at all. Because even after symmetry broke and matter was born, the universe still faced one final question. If every particle had its opposite, why did anything survive? When the universe was young, it was both generous and ruthless. It created matter and its mirror image, antimatter, in almost perfect pairs. Each particle was born alongside its twin, equal in mass, opposite in charge, like dancers facing one another. But when those partners met, they annihilated each other in flashes of light. If the universe had been perfectly balanced, every particle would have found its opposite, and everything would have vanished into pure radiation. No stars, no planets, no atoms, no you. And yet, something remarkable happened. For every billion pairs that vanished, one single particle of matter survived without its twin. One tiny survivor out of a billion. That small difference, that one extra note left playing after the song of creation, became the entire physical universe. Everything we see today, from galaxies to the smallest cell, is made of those leftovers, those 1 in a billion survivors. Scientists call this imbalance CP violation, a quiet rebellion against symmetry. It was first glimpsed in 1964 by two researchers, James Cronin and Val Fitch, who were studying the decay of strange particles called kaons. They noticed that these particles did not behave exactly like their mirror reflections. In the tiniest corner of physics, the universe had made a choice, favouring matter over antimatter, choosing existence over erasure. That small imperfection changed everything. It's easy to miss how delicate that choice was. Imagine flipping a coin 1 billion times, and it lands perfectly balanced between heads and tails every single time except once. That single coin toss, that single imbalance, becomes the reason you're here. The fact that the universe leaned ever so slightly toward matter is why there are oceans and mountains, why there is music and laughter and breath. Without that bias, there would be nothing left but light fading endlessly into silence. The reason for this imbalance still puzzles scientists. We know it must have happened within the first second after the Big Bang, when the universe was a blazing sea of particles colliding and transforming faster than thought. Somewhere in that storm the symmetry cracked. Perhaps it was a property of certain heavy particles, or perhaps a deeper principle of the cosmos itself, a rule that prefers existence to emptiness. Whatever the cause, that imperfection became the foundation of all structure, of every atom's stubborn refusal to vanish. In that single second, the arrow of time also found its direction. Time, you see, has no reason to move forward rather than backward, except for the fact that energy spreads and order dissolves. The universe began in an incredibly organized state, hot, dense, uniform, and has been unfolding ever since into complexity, into stars and dust and life. Each new degree of disorder marks another heartbeat of cosmic time. The forward flow we feel is the story of energy finding new ways to rest. Entropy, the scientists call it. But we might just call it the memory of motion, the universe remembering where it came from and how far it has drifted. Entropy isn't chaos, it's opportunity. It's what allows change. If the universe were perfectly ordered, nothing could evolve, because nothing could surprise itself. is because things can mix, decay, and move apart that time exists at all. Every breath you take, every thought that sparks in your brain adds to this slow, graceful unwinding. Your body radiates heat into the air, the earth radiates it into space, the universe radiates it into silence. But in that radiation, that gentle giving away of energy, new patterns always emerge. From entropy, complexity blooms. From decay, new motion begins. And so the arrow of time once set could not turn back. The preference for matter over antimatter gave the universe its structure. The preference for disorder over order gave it its rhythm. Together, they made reality not static, but alive. Every sunrise is a continuation of that first asymmetry, every movement a small echo of the universe's initial tilt toward becoming rather than not being. If you've ever watched cream swirl into coffee, you've seen a miniature version of this story. The dark and the light mix until they form something new, not uniform but full of texture and flow. It's beautiful because it's temporary, because it can never return to its original state. That's what time is, the motion from purity to mixture, from perfection to experience. And just as the cream never unmixed itself, the universe can never unmake its own history. Time, once broken free, cannot be reversed. We sometimes think of the past as something gone, but physics tells us it's still here, woven into the fabric of space-time, like layers of paint beneath the present moment. The difference is that we can't move backward through it because the universe itself is expanding forward. The flow of energy, the diffusion of light, the aging of stars, all of it drives time in one direction. If you could somehow reverse every particle's motion, every quantum of energy, you might unspool time itself. But you would also unmake everything that has ever lived. There's something strangely comforting in this. It means that imperfection is not an accident. It's the heartbeat of existence. The universe didn't fail when it became uneven. It succeeded in creating contrast, warmth, and memory. In a perfectly symmetrical world, there would be no motion to notice, no difference to experience, no consciousness to wonder. Life exists precisely because the universe was just slightly imperfect enough to care. When we look at ourselves, we often search for balance, for symmetry, for perfection. But the cosmos reminds us that balance is born from imbalance. The tilt of the Earth gives us seasons. The irregular orbits of planets prevent monotony. Even your heart doesn't beat at a perfectly constant rhythm. It quickens when you laugh, slows when you rest. The small deviations are the signs of life, the echoes of that first cosmic flaw. So perhaps we owe everything, time, light, awareness, to the fact that the universe once leaned ever so slightly toward one side of its reflection. We are that lean. We are that preference, frozen into atoms, expressed through consciousness. The stars didn't have to survive their mirror annihilation, but they did. And so, here we are, thinking about it. Take a slow breath. The air you just inhaled was once part of a star that burned billions of years ago, part of a cloud that drifted, part of that 1 in a billion imbalance that refused to vanish. Every atom in you carries the signature of the universe's first decision, to be something rather than nothing. And as we follow that decision forward, our story begins to reveal another layer of motion, the invisible hand that holds all of this together. Because even though the universe is imperfect, it doesn't fall apart. Something unseen keeps its spinning worlds in place, guiding stars in graceful spirals, balancing what should have scattered long ago. The next part of our journey turns to that hidden architecture, the dark framework that gives form to everything we see. If you were to look at a galaxy from far away, it would seem to defy logic. Hundreds of billions of stars whirl around a glowing centre, their light trailing like brushstrokes on black velvet. They move so quickly that by every visible law they should have flown apart long ago. And yet they don't. Something unseen is holding them together, something vast, silent, and invisible. The story of that unseen presence began almost a century ago with a quiet Swiss astronomer named Fritz Zwicky. In the 1930s, he was studying a cluster of galaxies called Coma, a distant swarm of light moving together through space. When he measured their speeds, he noticed something odd. The galaxies were racing far too fast to be bound by the gravity of the matter he could see. There wasn't enough visible mass to hold them in orbit. By all rights, they should have scattered into darkness, but they hadn't. Zwicky proposed that there must be something else, an unseen glue that provided the extra gravity. He called it Dunkle Materie, dark matter. Few believed him at first. The idea seemed almost too invisible to be true. But decades later, another observer picked up the trail. In the 1970s, astronomer Vera Rubin spent night after night measuring the speeds of stars in spiral galaxies. She expected to find that stars near the edge of a galaxy moved more slowly than those near the centre, just as the outer planets of our solar system orbit more slowly than the inner ones. But that's not what she found. The stars at the edges were moving just as fast as those near the core, far too fast for the galaxy's visible mass to contain them. Something unseen, she realised, must be providing the missing pull. She described it in simple words. The stars are moving too fast for the light we see. That single sentence reshaped our understanding of the cosmos. Vera Rubin had uncovered proof of Zwicky's invisible matter, the quiet hand that steadies the spinning galaxies. Since then, astronomers have mapped the universe with ever greater detail, and the same pattern appears everywhere. When they simulate the motion of galaxies without dark matter, the systems collapse or fly apart. But when they add it, when they fill space with a hidden halo of mass, the galaxies behave exactly as they should. The invisible glue works perfectly, even if no one has yet seen the glue itself. You can imagine dark matter as a vast transparent web surrounding every galaxy. The stars and gas you see are only the brightest beads threaded on its filaments. In computer simulations from NASA and the European Space Agency, these invisible webs look almost like veins of glass or ice, delicate branching structures that stretch across hundreds of millions of light years. They form what scientists call the cosmic web, a pattern of dark filaments cradling the luminous galaxies like dewdrops caught in a spider's silk. We know dark matter must be there because of how it bends light. When beams of light from distant galaxies pass near massive clusters of dark matter, they curve, just as rays of sunlight bend through a glass of water. This effect is called gravitational lensing, and it lets astronomers map the invisible by studying the distortions in the light we can see. The most famous example is the Bullet Cluster, two colliding clusters of galaxies that passed through each other long ago. The visible galaxies went one way, their hot gas went another, and the dark matter, unaffected by collisions, drifted between them. The light from background galaxies bent around this invisible mass, revealing its presence like fingerprints on glass. It was as if the universe had momentarily lifted its veil to show the hidden scaffolding beneath. No one yet knows what dark matter is made of. It doesn't emit or absorb light. It doesn't interact with normal atoms except through gravity. It may be composed of particles we've never detected, perhaps massive but slow-moving ones that pass through us by the trillions every second, unnoticed. If you held out your hand, right now countless dark matter particles would be gliding through it, through your skin, through the Earth itself, leaving no trace but their pull. Some theories suggest dark matter might not be particles at all, but a subtle modification of gravity, an unseen rule rather than an unseen substance. Others imagine fields that hum quietly across space, or ghostly companions to ordinary particles called axions, lighter than light itself. We don't know which story is true, but every new observation draws the picture more clearly. Galaxies move the way they do because the invisible outweighs the visible. It's humbling, really, to realize that most of the universe is made of something we cannot see. The stars, planets, and atoms that make up everything familiar. All of that accounts for less than 5% of the total. The rest is dark matter, and an even more mysterious ingredient called dark energy. We live in a universe that hides 95% of itself, and yet that hidden part gives shape to everything we know. Perhaps that's what makes the idea so hauntingly beautiful. Dark matter is not absence, it's presence without display. It's gravity without glow, structure without sound. The galaxies whirl in its grasp like dancers following an unheard rhythm. Their light moves through invisible corridors, curving gently through the dark. Every star you see tonight owes its position, its orbit, its stability to this unseen framework. There's a kind of poetry in that. We often think of darkness as emptiness, but here it's the opposite. The dark is what holds the light together. The visible universe, all its stars and colours and heat, is only the surface of a much deeper pattern, a shadow that reveals its shape only by how it bends the brightness around it. So when you look up at the night sky and see the Milky Way stretching across the heavens, remember that you're not seeing the galaxy itself, not entirely. You're seeing only the luminous part, the frosting on an invisible cake. The real mass, the real architecture, lies hidden beneath, silent but faithful, holding every star in its orbit, every spiral in its curve. The universe, it seems, is held together by what it refuses to show. And if we follow that thought further, our next step takes us into the heart of discovery. How scientists have learned to trace this invisible structure, using light itself as their tool. Because even shadows can be mapped, if you know how to listen to the way they bend the glow of distant stars. The universe hides most of its weight in shadow, but light, ever curious, refuses to ignore it. Even the faintest ray, travelling for billions of years, remembers every curve and bend it has passed through. And by tracing those distortions, we've learned to map what cannot be seen, to draw the outlines of the invisible. Imagine light as a traveller moving across the cosmic sea. Normally it moves in straight lines, like an arrow through still air. But space is not perfectly still. It is curved and stirred by gravity, thickened where matter gathers, stretched thin where emptiness reigns. When light passes through these invisible currents, it bends, not sharply, but gently, like sunlight refracting through water. This bending is called gravitational lensing, and it has become our most sensitive way of seeing dark matter. The concept sounds like something out of poetry, using brightness to reveal the dark. In a way, it's as though light itself is whispering the shape of what it cannot touch. When astronomers study distant galaxies, they notice that their shapes are sometimes subtly distorted, stretched into arcs, duplicated into ghostly reflections, or curved into glowing rings. These patterns are the fingerprints of hidden mass bending the space between us and them. The most striking examples come from massive clusters of galaxies that act as giant cosmic lenses. The cluster's dark matter halo bends light from galaxies behind it, creating arcs of luminous echo. The Hubble Space Telescope has captured many of these, elegant spirals of light bent into crescent shapes, each one a quiet confession of gravity unseen. When computer models reverse engineer these arcs, they reveal detailed maps of dark matter, halos, filaments, and knots of invisible density, like veins beneath translucent skin. But as beautiful as these images are, they are only the beginning. To truly chart the hidden universe, astronomers have built new telescopes designed not just to look at stars, but to listen to light itself, to measure how it warps and stretches under gravity's invisible touch. One of these eyes on the cosmos is the Euclid mission, launched by the European Space Agency. Floating 1 million miles from Earth, Euclid will spend years mapping billions of galaxies across more than a third of the sky. It won't see dark matter directly, but it will chart the faint distortions in light caused by its pull, turning those distortions into a cosmic cartography of the unseen. Each subtle shift in a galaxy's shape becomes a clue to the invisible structure around it, building a three-dimensional map of the universe's hidden skeleton. NASA's Nancy Grace Roman telescope, planned to join Euclid's effort, will refine that map even further. Its wide field of view will allow it to capture immense patches of sky at once, measuring the small warps that individual galaxies alone could never reveal. Together, Roman and Euclid will act like twin eyes, giving humanity stereo vision, depth perception for the dark. Meanwhile, the James Webb Space Telescope has already shown how far light can carry a message. By peering into the faintest galaxies billions of years old, Webb reveals how early cosmic structures formed, guided by dark matter's gravitational scaffolding. The galaxies Webb sees are only the glowing tips of immense invisible roots, drawn together by an unseen web that shaped the first stars long before light filled space. To imagine what this looks like, picture a vast pane of glass, cold and flawless. Now imagine ripples forming across it, waves that bend the view of everything behind them. That's how the universe appears to light. Space itself becomes a lens, its invisible curves shaping what we see. Some of these distortions are sharp, forming dramatic rings or arcs. Others are subtle, detectable only by measuring thousands of galaxies at once and finding the smallest statistical tilt. In either case, the story is the same. Light is our messenger, tracing the paths carved by dark matter's gravity. And as we listen more carefully to that light, we begin to wonder, what exactly is this invisible matter made of? Scientists have imagined several possibilities. One family of candidates is known as WIMPs, weakly interacting massive particles. If they exist, they would be heavy but almost perfectly indifferent to everything except gravity. They would pass through ordinary matter like ghosts, without colliding, without shining. Another candidate is the axion, a particle so light it behaves more like a vibration than a thing, rippling softly across space like an invisible breeze. There are even bolder ideas, that dark matter could be made of primordial black holes, or something stranger still, like a hidden mirror version of our own universe, overlapping ours but never touching. The search for these particles is delicate. Deep underground, in labs shielded from cosmic rays, scientists build detectors filled with liquid xenon, enormous, quiet tanks waiting for the faintest flash of light that might betray a dark particle brushing through. Years can pass without a signal. But the waiting itself is an act of faith. Faith that the universe's silence hides meaning, not emptiness. And yet, perhaps dark matter will never be caught that way. Maybe it isn't a thing to be trapped, but a pattern to be understood, a kind of gravitational whisper woven into the fabric of space. Some cosmologists have suggested that it might be an emergent property of space-time itself, the result of the way information and entropy shape the universe's geometry. If that's true, then dark matter isn't something separate at all, but a natural expression of the cosmos remembering how to balance its spin. Whatever the answer, one truth remains: we are surrounded, supported, and steadied by the unseen. Every orbit of the Earth, every turn of a galaxy, every reflection of starlight across billions of light years, all depend on the quiet gravity of what we cannot detect. It's humbling to think that light, in all its brilliance, needs darkness to define its path. Without shadow, illumination has no shape. Without the unseen, there is no seen. We navigate a cosmos where the brightest truths depend on invisible foundations. Perhaps that's the final lesson of dark matter, that the unknown is not an absence, but a structure waiting to be traced. Light bends through it, stars cling to it, and we, small observers on a spinning world, move safely within its invisible embrace. So the next time you see a photograph of a galaxy, remember that what you see is not the whole story. Behind every sparkle of light lies an unseen architecture, silent, eternal, patient, guiding each motion, each orbit, each turn. We live inside a universe balanced by what cannot be seen. And as our quiet journey continues, the trail now carries us towards something more intimate, from cosmic shadow to the delicate geometry of life itself. Because even within us, in the folds of chemistry and DNA, the universe's love of direction and spin still endures. Hold out your hands for a moment. Look at them closely, one palm mirroring the other, fingers aligned yet opposite. They seem identical, and yet if you tried to fit one glove onto the wrong hand, it would never sit quite right. This simple mismatch hides one of the great secrets of biology. Life itself, from your DNA to the smallest molecule in a leaf, also has a preferred hand. This property is called chirality, from the Greek word for hand. Molecules like your palms can exist in two mirror forms, one left-handed, one right-handed. They're made of the same atoms, arranged in the same shapes, yet when reflected they refuse to overlap. It's a small difference, but nature treats it as sacred. Nearly every living thing on Earth uses left-handed amino acids to build its proteins and right-handed sugars to build its DNA. Reverse them and life falls apart. The chemistry stops working, as if the key no longer fits the lock. It's one of those mysteries that feels both obvious and profound. Why this direction and not the other? Why left and not right? Nothing in the basic laws of chemistry requires it. When scientists make amino acids in a lab, they form both versions equally, left and right, mirror twins in perfect balance. But life, somewhere along its long history, broke that symmetry. It chose a side and has been loyal to it ever since. To imagine how strange this choice is, picture a planet where every living thing were mirrored, where all hands, shells and spirals turn the opposite way. You could build it in theory, but it would be incompatible with our own biology. A right-handed protein could not fold correctly inside a left-handed cell. The two forms would pass through each other like ghosts. If life ever exists elsewhere in the universe, one of the most exciting questions will be this: did it choose the same hand as we did, or the opposite? Scientists have found hints that this preference might predate Earth itself. In 1969, a meteorite landed near the town of Murchison in Australia. When researchers studied its organic compounds, they found something remarkable. The amino acids inside showed a small but consistent bias toward the left-handed form, the same one used by all life on Earth. Another piece of cosmic evidence came from the Rosetta spacecraft, which in 2014 approached the comet 67P. Instruments aboard detected molecules that also favoured the left. These ancient visitors carried a hint that the universe had already leaned one way before life began. Perhaps the bias began in the clouds of dust and ice that surrounded the young sun, where radiation from nearby stars bathed the forming planets in polarised light. Light that, due to its orientation, interacts differently with left-handed and right-handed molecules. Over millions of years, one form might have been ever so slightly favoured, multiplied, and finally passed along to the first self-replicating molecules. A tiny advantage spread across cosmic time became destiny. There's something quietly poetic about that a beam of starlight tilted just enough could have decided the shape of every cell, every spiral, every living form to come. You carry the memory of that ancient starlight in your very body, in the way your DNA twists, in the curl of your fingerprints, in the spiral of your hair. This idea of handedness appears everywhere once you start looking. Seashells spiral clockwise or counterclockwise depending on their molecular makeup. Snails, flowers, and even galaxies show preferences for direction. Tornadoes in one hemisphere twist one way, in the other they turn the opposite. Not by coincidence, but because rotation and direction are built into the physics of motion itself. The universe seems to dislike perfect neutrality. It chooses. Life's left-handedness is one small echo of that larger truth. It's as if the cosmos itself spun once long ago and whispered its preference into everything that followed. The spiral of a fern uncurling in spring, the path of water circling down a drain, the coiling of your DNA, all might be distant reflections of that first cosmic spin. And yet, the mystery remains. We can explain how handedness continues, but not exactly how it began. Once the first left-handed molecules dominated, they replicated themselves, copying their own geometry over and over, ensuring that life stayed aligned. But how the very first asymmetry appeared may always be unknown. Perhaps it was chance, a single fluctuation, amplified by time. Or perhaps the laws of physics themselves contain a small tilt, a subtle preference written into their equations, guiding matter toward a particular orientation. Some physicists think the answer might lie in the weak nuclear force, one of the four fundamental forces of nature, responsible for certain types of radioactive decay. Unlike most forces, it breaks mirror symmetry. It distinguishes between left and right. Experiments in the mid-20th century revealed that some particles decay in a way that prefers one direction of spin over the other. It was as if the universe, even at its deepest level, had already chosen a hand. Biology, then, may simply have followed suit. It's almost comforting in a strange way to think that our own bodies echo that ancient decision. Your DNA's rightward spiral isn't random. It's a continuation of a cosmic preference that stretches back to the first seconds after the Big Bang. When you look at the spiral of a galaxy or the curl of a vine, you're seeing the same principle, repeated at vastly different scales. The direction of life is the direction of the universe itself, one continuous gesture, from the spin of atoms to the spin of stars. So much of existence depends on these quiet, invisible alignments. If life had chosen the opposite hand, perhaps everything would be reversed. The way proteins fold, the way hearts develop, even the way the brain organizes thought. Our reality would still work, but it would be utterly alien. We might never recognize it as familiar. That small asymmetry, that subtle lean toward one side, defines the structure of everything we know. When you touch your left hand to your right, remember that you are touching two versions of the universe's choice, one that exists in symmetry and one that lives because symmetry was broken. Life does not stand at the center of this story. It is one of its outcomes, a graceful continuation of a pattern that began long before the Earth cooled. Perhaps that is why we find spirals so soothing in seashells, galaxies, or fingerprints. They remind us of the flow that connects everything, the same turning that shapes stars, storms, and cells alike. They are the handwriting of motion itself. Life chose a direction, and it has been following it ever since. As we drift further into the story, the path now carries us beyond the boundaries of biology and back into the cosmos, toward the very light that may have written these directions into existence. Because before molecules could choose their shape, light had already learned to twist, and in that twisting, it may have decided the shape of life. If you trace life's spiral back far enough, before oceans, before molecules, before even the dust that became the Earth, you find light. Not just illumination, but light as a sculptor, twisting, polarizing, choosing a direction long before life knew what left or right even meant. Light is not as simple as it seems. It doesn't just travel forward, it dances. Each wave spins as it moves, tracing tiny circles as it travels through space. This spin can be left-handed or right-handed, a property called polarization. Most of the light around you, from your lamp, the sun, or the stars, is a jumble of both directions, balancing each other perfectly. But in certain corners of the cosmos, that balance breaks. When starlight bounces off magnetic fields or dust clouds or passes through regions shaped by intense rotation, it becomes polarized. It leans toward one spin. And it is possible that this subtle bias, carried across billions of miles, once fell upon the raw chemistry of early Earth and whispered its preference into the molecules that would later awaken as life. Imagine the early solar system, a young sun surrounded by a disk of gas and dust, swirling like a slow storm. Comets and meteors drift through that haze, coated with frozen gases and simple molecules. From time to time, a bright pulse of light from a nearby star passes through, its waves slightly polarized, its spin tilted one way. That light reaches the icy grains, interacting more strongly with molecules of one-handedness than the other. Over countless years, one version survives just a little more often. Left-handed amino acids, right-handed sugars, until, by persistence rather than perfection, the pattern becomes dominant. When those comets and asteroids later crash onto the forming Earth, they bring this small imbalance with them, seeds of molecular direction that will soon take root in oceans, in chemistry, in cells. And so a cosmic gesture becomes a biological law. Light, through its spin, decides the shape of life. We see this mirrored everywhere. Sunlight, when reflected off clouds of dust in space, shows a faint polarization, a preferred direction in its waves. The same effect happens on Earth when light scatters through the atmosphere. It's why the sky's colour changes with angle, why polarised sunglasses can make reflections disappear. Polarisation is light remembering how it turned. In that memory lies a clue. If light can carry a twist, and if that twist can influence matter, then every spiral, from DNA to galaxies, may be following the same choreography. Even physics seems to agree. Deep within the subatomic world, the universe already shows a preference for direction. When certain particles decay, they don't do so symmetrically. They favour one spin, left, not right. It's a phenomenon called parity violation, discovered in the mid-20th century. In 1956, physicist Qian-Sheng Wu and her team cooled cobalt atoms near absolute zero and watched them decay. The results shocked everyone. The emitted electrons didn't spray evenly in all directions. They leaned consistently to one side. The mirror universe, it seemed, was not perfect after all. That discovery changed how we understood reality. It meant that at the most fundamental level, the cosmos itself prefers a handedness. The weak nuclear force, one of the four basic forces of nature, only acts on left-handed particles. Right-handed ones are simply ignored, as if the universe only shakes one hand and not the other. Biology, it seems, has followed the same etiquette ever since. When you think about it, this symmetry breaking is woven into everything we know. Our planet spins eastward, making the sun rise and set. The weather systems curl clockwise in one hemisphere and counterclockwise in the other. Storms have handedness. So do galaxies. The Milky Way's spiral arms lean in a particular direction, the same way your DNA does. The scale changes, but the rhythm remains. It's as though the entire universe were built on a single rotation, echoed again and again, from the tiniest particle to the largest cluster of galaxies. And if this seems too poetic to be true, consider this. The same equations that describe the twisting of light waves also describe the swirling of fluids and the spinning of electrons. Every form of motion carries a kind of spin, and that spin carries a preference. Perhaps the pattern of left and right, of clockwise and counterclockwise, is not an accident, but a memory, a relic of the universe's first turn. There's something quietly human in this story too. You, reading this now, are the descendant of light's choice. Your body's molecules all share the same orientation because ancient starlight once nudged chemistry one way instead of the other. You might say that light itself chose the architecture of your cells, and when you look at the glint of sunlight on water, You're seeing the same force that shaped the curve of your own DNA. It's humbling to imagine that photons, particles of light with almost no mass and no rest, could decide something so fundamental. But that's what makes the universe so strange and so tender. Its smallest gestures ripple outward into eternity. The way light turns determines the way life forms. The way a particle spins helps decide the direction of a storm, the tilt of a flower, the path of a galaxy. From one perspective, it's all just physics, equations describing waveforms and probabilities. But from another, it's the poetry of creation. Light doesn't just illuminate the universe, it choreographs it. It carries memory in motion, information in spin, direction in dance. Every polarized photon that has ever touched a molecule has whispered a preference, a tilt, a direction that the rest of the universe followed. Maybe that's why we find spirals everywhere we look, in whirlpools, in pine cones, in the shells of snails. The spiral is what happens when symmetry begins to move. It's the shape of balance in motion, the visible trace of the universe's desire to turn. Every swirl, every curl, every helix is the world remembering that first cosmic twist. And as we follow that spiral further, we begin to sense the next truth. Motion, no matter how eternal it seems, doesn't last forever. Every spin slows eventually, every rhythm fades. The same forces that create structure also erode it. Even the stars, those great engines of rotation and light, will one day lose their spin. In the next part of our journey, we'll drift gently into that slow unwinding, into the long future of motion itself, where rotation gives way to stillness, and stillness becomes a different kind of beauty. Because even as everything slows, the memory of movement remains. Every movement, no matter how grand, carries within it a quiet promise that one day it will slow. Spin is not eternal, only patient. Even the universe, which began in a whirl of creation, is gently losing its rhythm one rotation at a time. You can almost think of it as the soft exhale after a long, luminous song. Our own planet shows this truth in miniature. Earth does not spin as quickly as it once did. Billions of years ago, when it was young, a single day lasted only 6 hours. The tides were stronger then, the moon closer, a looming companion that churned the seas and tugged the planet's crust like a restless heartbeat. Over time, that gravitational pull became a brake. With each tide, a little energy was transferred from the Earth's rotation to the moon's orbit, slowing the planet's spin and pushing the moon slowly farther away. The change is almost imperceptible now, only about 1.5 thousandths of a second added to each day every 100 years. But it's steady, patient, unstoppable. The moon drifts away from us at the pace your fingernails grow, and our days quietly lengthen. It's strange to think that if life had evolved a little earlier, its heartbeat might have been tuned to a faster rhythm, its sleep shorter, its sense of time entirely different. You can see similar patterns throughout the solar system. Venus spins so slowly that a single day there lasts longer than its entire year. The sun rises in the west and sets in the east because Venus rotates backward, a motion astronomers call retrograde. No one knows exactly why. Perhaps long ago it collided with another large body, a cosmic nudge that flipped its rotation like a coin. Mercury, on the other hand, has found a strange compromise. It spins 3 times for every 2 orbits around the sun, a resonant rhythm that keeps one face always near the heat of daylight, the other in near permanent twilight. Each world carries its own signature of slowing, its own way of surrendering to the quiet gravity of time. Even stars, the engines of light, cannot spin forever. When young, they turn rapidly, their plasma flowing like boiling water, magnetic fields whipping across their surfaces. But as they age, they lose energy through their light and their winds. Over billions of years, those stellar winds carry away angular momentum, a soft drag that slows the star's spin. Our sun once rotated much faster than it does now. Today it completes a turn every 27 days at its equator, and even that rate is slowing. One day, long after it has swollen into a red giant, it will rotate so slowly that its outer layers will drift away, leaving behind a quiet ember, a white dwarf, barely turning at all. And the slowing doesn't stop there. On much larger scales, galaxies too are losing their spin. When two galaxies collide, their graceful spirals twist into chaotic shapes. The stars themselves rarely collide, space is too vast, but their collective motion changes. Some of the spin is converted into heat, into the random motion of stars now orbiting in new patterns. Over time, the sharp spiral arms soften into the smooth ellipses of older galaxies. Our own Milky Way is already on this path. In about 4 billion years, it will merge with its nearest large neighbour, the Andromeda Galaxy. Right now, both are swirling majestically through space, each containing hundreds of billions of stars. But when they meet, their orbits will tangle, their arms will stretch and twist, and their central black holes will spiral toward each other in a slow, immense embrace. The result will be a single rounded galaxy, quieter, slower, but richer in starlight. Astronomers have already given it a name, Milkdromeda. If you could watch that event unfold, sped up across eons, you might find it surprisingly peaceful. The two galaxies would pass through each other like ghosts, their stars barely touching, while vast tides of gas and dust ripple outward. It would be a cosmic dance in slow motion, a fading waltz written across billions of years. When the last of the chaos settles, the new galaxy will rotate more slowly than either of its parents. The great swirl of motion will have softened into something calm, something resembling rest. The same slowing rhythm echoes everywhere. Pulsars, those dense, spinning remnants of collapsed stars, rotate hundreds of times per second when they're born. But they too lose speed as they radiate energy into space, their pulses gradually stretching apart over millennia. It's as though even the universe's most relentless clocks are counting themselves down. This gradual fading isn't decay, it's transformation. Motion never truly disappears, it changes form. The energy of rotation can become warmth, light, or gravity waves rippling outward. Each slowdown feeds another process, another act of creation. The spinning of Earth slows the tides stir the seas shape the weather, and the weather shapes the living world. Even as motion diminishes, it leaves gifts behind. Perhaps this is the universe's quiet way of teaching balance. Everything that spins eventually shares its energy with what surrounds it. Nothing hoards motion forever. Each rotation, from atom to galaxy, eventually contributes its momentum to something else. A tide, a collision, a ripple, a wave. The slowing of one thing becomes the movement of another. If you listen to this pattern long enough, it starts to feel familiar. You can feel it in your own life, in the slowing of breath as you rest, the easing of thought as night comes, the way time itself seems to stretch as you grow older. The same physics that tugs at galaxies also works gently within you, turning movement into stillness, effort into calm. There's no tragedy in this. The universe doesn't mourn its slowing, it simply changes tempo. The early cosmos was a rapid symphony, stars forming, galaxies colliding, light bursting forth. Now it moves in slower harmonies. The notes linger, the rhythm relaxes, and one day, when all the grand motions have quieted, the universe may reach a kind of equilibrium, not lifeless but serene. Even the stars are slowing their breath, and as we drift toward that distant horizon of stillness, our story now carries us deeper, to the far future of the cosmos itself, where motion thins until it becomes memory, and time stretches out into silence. For even when every spin fades, The echo of that first turning remains, written softly across the dark. There will come a time, far beyond all calendars, when motion itself will fade into a kind of stillness. It will not happen suddenly or dramatically, but with the same patience that galaxies have always shown. The universe will grow old gently, like an ocean calming after an endless tide, and though its energy will never vanish, it will stretch so thin that nothing will remain to feel its warmth. This long future is sometimes called the heat death, though the name is misleading. It isn't a violent end, but a gradual quieting, a cooling of motion, a thinning of contrast. Heat, after all, is just the movement of particles, and when everything moves at nearly the same pace, there is no warmth to notice. No more gradients, no more flow, just equilibrium, a cosmic exhale. We can already glimpse the process in the way stars slow and fade. When a star dies, it sheds its outer layers and collapses inward, becoming first a white dwarf, then a black dwarf, an object so cold and still that it no longer shines. It might take 1 trillion years for that to happen, but the universe has no reason to hurry. Around these remnants, planets will have long since frozen, their oceans locked in glass. Even black holes, those gluttons of gravity, will begin to lose their energy. It's hard to imagine that anything could slow a black hole, yet even they are not immune to the universe's gradual unwinding. In the 1970s, Stephen Hawking proposed that black holes are not perfectly black. Through the subtle quantum fluctuations near their edges, they emit faint radiation, a whisper of heat leaking from their boundaries. Over unimaginable spans of time, this Hawking radiation allows black holes to evaporate, shrinking until they finally vanish in a brief flicker of light. It's not an explosion, but a sigh. The last echo of motion turning into memory. Before that distant moment, though, the universe will still be whispering. Pulsars, those dense, spinning remnants of collapsed stars, will continue their rhythm, flashing beams of light like cosmic lighthouses. But with each passing eon, their rotation will slow, their energy radiating away into the dark. Eventually, they too will go quiet, leaving only faint electromagnetic ghosts, the afterimage of motion that once was. Even the galaxies themselves will drift apart. Space is still expanding, and that expansion is accelerating. The light from distant galaxies already takes billions of years to reach us, and as time stretches further, those galaxies will recede faster and faster until their glow fades beyond any possible horizon. The universe will become lonely, each island of matter isolated by distances so vast that no light can bridge them. The night sky will grow empty, its familiar constellations dissolved into silence. Yet the emptiness won't be truly empty. All the atoms, all the photons, all the particles that once formed stars and people and thoughts will still exist, just quieter, cooler, slower. Temperature will fall to near absolute zero, a state so still that time itself will seem to lose meaning. Every form of energy will have spread out evenly, no longer capable of doing work or making change. Motion will have diffused into stillness, but even in that stillness something remains. Energy cannot be destroyed, it only transforms. Every movement that ever was will persist as a trace, a subtle curve in space-time, a faint hum in the cosmic background. Space itself will remember. It always has. When we talk about the fabric of the universe, it isn't just a metaphor, it's a record. Every rotation, every orbit, every spark of light leaves a small imprint, a gentle twist in the geometry of everything. In that sense, even the quietest universe is still full of echoes. If you could stand at that distant edge of time, impossibly far in the future, you might not see anything, but you could imagine it. A dark cosmos, smooth and vast, its temperature hovering just above zero. No stars, no galaxies, no planets, only invisible ripples drifting through space, relics of ancient gravities, carrying the last signatures of motion. The Laser Interferometer Space Antenna, a mission humanity plans to launch in the coming decades, will listen for such ripples in our own era. The faint waves produced when black holes merge. But in the far future, no detectors will remain to listen. The ripples will still be there, but they will pass unobserved, like music long after the listener has gone. And yet, the beauty of this vision isn't in despair. There's peace in it, the peace of completion. Just as the ocean's surface eventually smooths after a storm, so too will the universe find its balance. The constant push and pull of energy, the collisions and creations will slow into harmony. Motion won't end, it will simply stop changing. Every atom will move in rhythm with every other, perfectly balanced, perfectly still. What remains then is not movement, but the memory of movement, a soft imprint in the silence, like footprints preserved in cooling sand. The story of the universe will still be written there, not in stars or light, but in the structure of space itself. Every whirl of a galaxy, every heartbeat of a star, every breath ever taken, all of it will have left its trace. The universe, even in its long sleep, will remember that it once danced. There's a certain comfort in that thought. The end of motion is not the end of meaning. It's simply the slowing of a rhythm too vast for any of us to hear in full. If time is the music of motion, then heat death is the final chord, long, soft, and eternal. So when you look up at the night sky and see the stars slowly wheeling above you, remember that you are watching motion itself in the act of remembrance. Every rotation you see is a note in the song that will one day fade into quiet. And when that quiet finally arrives, it won't be emptiness, it will be rest. The universe breathing out, content in what it has created. And as our journey drifts into its final act, we'll turn from the outer universe back toward ourselves, toward the one part of reality that still carries motion's memory in a living form. For even as the stars slow and the galaxies fade, there remains something that still turns, still remembers, still wonders. Consciousness, the quiet echo of motion within us, the universe thinking about its own spin. If you were to pause right now and listen closely, not with your ears but with your awareness, you would still feel movement. Not the kind you can measure, but the kind that lives beneath every heartbeat and breath. Even when you are still, you are spinning. Every atom in you is a small compass, a particle of the universe continuing its ancient turn. Every thought you have is a ripple of electricity, a tiny wave of charge travelling across the surface of your mind. You're not separate from motion, you're made of it. It's strange to think that the same physics that drives galaxies also plays out inside your body. But it does. Each atom in your cells has a nucleus that spins, surrounded by electrons that dance in quantized rhythms. Those particles in turn are made of smaller entities, quarks, that carry their own intrinsic rotation. Their property physicists call spin. It's not spinning the way a planet or top does, but a kind of built-in rotation, a signature of identity. Every particle has it. Spin is the reason atoms form magnetic fields, why matter holds shape, why the world has structure. It's also the reason you can sense, think, and exist. In a way, every living brain is a library of motion. Your neurons fire in oscillations, not random sparks, but organized waves, each frequency carrying a function: memory, perception, sleep, awareness. When you close your eyes and drift into rest, those waves slow, then synchronize, like a tide returning to shore. Consciousness itself may be nothing more than motion, arranged in intricate patterns, particles moving, currents aligning, electric fields interacting. Awareness, then, is the universe remembering its own movement through you. You don't need mathematics to understand this. You can feel it. When you breathe, when you sense your pulse in your fingertips, when you watch clouds drift across the sky, every rhythm is a continuation of something that began billions of years ago. The spin of electrons keeps chemistry alive. The rotation of the Earth keeps time. The beating of your heart, steady and patient, is another echo of that cosmic pulse. From the subatomic to the planetary to the personal, the pattern repeats. Motion creating rhythm, rhythm creating memory, memory creating life. If the universe ever had a purpose, perhaps it was this: to remember itself, to turn, to evolve, to notice that it was turning. The first stars formed, lived and died, scattering heavy elements that later built planets and people. Those atoms, once locked in stellar cores, are now inside your brain, circulating as electrical impulses. Every thought you have is powered by the decay of elements born in supernovae. When you think about the stars, you are thinking with their ashes. The cosmos became conscious enough to recall its own story. Scientists sometimes call this the emergent property of complexity, when matter organizes itself so intricately that new behaviors appear, like awareness or intention. But you could also call it a kind of memory. The universe doesn't hold thoughts the way you do, yet it records everything through its motions. Every orbit, every photon, every gravitational wave leaves a trace in the fabric of space-time. Einstein showed that when something moves or has mass, it leaves a permanent curve behind, like a brushstroke on an invisible canvas. Those curves never truly vanish. The universe remembers through geometry, and you remember through consciousness. The difference is only one of scale. Think of how memory feels in you: a sense, a pattern, a reoccurring rhythm that replays itself. It's not so different from the way the cosmos holds its history. The ripples in the cosmic microwave background, the faint afterglow of the Big Bang, are the universe's oldest memory. Frozen waves of light still stretching across the sky. In their patterns lies the record of the first vibrations, the first oscillations of matter and energy. They are quite literally the fossilized rhythm of creation. Your own memories work the same way, though at a smaller scale. They are not static pictures, but dynamic processes, neural connections reinforced by a repeated motion, tiny electrical storms that replay familiar patterns. When you recall a moment, you recreate the same firing sequence in your brain. You are, in essence, repeating the same movement of energy that once flowed there before. The past, then, is not gone. It's simply waiting for your awareness to turn toward it. Even time itself may be a kind of memory, an accumulation of change, a record of motion that keeps unfolding. When physicists describe the curvature of space-time, they're describing not just space, but history. Every motion leaves its imprint, and every imprint bends the path of what follows. You could say that time is the universe thinking about movement, one moment at a time. There's a quiet comfort in knowing that nothing truly still ever exists. Even in your moments of rest, you are participating in a cosmic current that has been flowing for nearly 14 billion years. The energy in your body was once starlight, trapped and transformed, now borrowed for a while before returning to the greater whole. The photons that touch your skin were born in the sun, which burns because its atoms are collapsing under gravity, a motion that began when the first hydrogen clouds swirled in the early universe. Everything you are is made from motion repurposed. Sometimes when you look at a spinning object, a planet, a wheel, a dancer, you might notice how difficult it is to tell when the motion truly began. The rotation seems eternal, as though it has always been. Maybe that's true for the universe too. The first turn never really stopped, it only became more complex. Each spin became smaller, more intricate, until it reached the scale of consciousness. Awareness is the universe's latest way of moving, one that doesn't involve distance or velocity but reflection. Perhaps that's what you are, the universe remembering itself through thought, through curiosity, through wonder. When you ask questions about how stars are born or why everything spins, that isn't separate from the cosmos. It is the cosmos through you, asking about its own design. You're the echo of motion contemplating motion, a spiral that has learned to think about its own turning. And maybe when everything slows, when galaxies fade and stars go out, this memory will still linger somewhere, embedded in the last traces of energy. The curves in space-time, the faint ripples of light, the geometry of your thoughts, all of it part of one vast interconnected remembrance. Motion cannot die, it only changes form. Consciousness too might be its gentlest form, motion folded inward into awareness, still moving even in silence. So as you lie still tonight, feel the subtle movement within you, the pulse of your blood, the rhythm of your breath, the steady spin of the planet beneath your body. All of it is memory. All of it is continuation. You're not an observer of motion, you're its echo. And as we approach the final chapter of this journey, the universe itself will take one last breath. Not to end the story, but to rest in it, to pause, to dream, and to remember that stillness is just another kind of motion seen from far enough away. And so, after all the turning, after all the orbits and echoes, the universe comes to rest, not in silence, but in a hush that feels like sleep. The story of motion, which began before time itself, has unfolded through stars, atoms, tides, and thought, and now it finds its quiet reflection in you. Everything that has ever turned still turns within you. Every breath you take continues a motion 13 billion years old. It's easy to forget as you go about your days how deeply connected you are to this great unfolding. The ground beneath you is spinning, the air around you is moving, the molecules inside you are vibrating in endless rhythms. Your heart beats not only because of biology, but because energy, born from the death of ancient stars, still hums in your cells. The warmth you feel on your skin from sunlight is the same light that once ignited the early galaxies. Every photon that touches you carries a memory of fusion, of gravity, of time's long spiral toward now. The universe has never stopped moving. It has only changed the ways it moves. What began as expansion became structure, then light, then life, then awareness. Now, in this quiet moment, you're part of its reflection. When you think about the cosmos is, in a way, thinking through you. When you wonder about the beginning, the universe wonders about its own birth. You're the continuation of curiosity itself, motion folded into thought. And perhaps, after all these turns, what the universe has been doing all along is learning how to rest. Every galaxy that slows, every star that fades, every heartbeat that steadies is a step toward balance. The story of creation isn't one of endless energy, but of movement seeking harmony. Motion finds its completion not in more motion, but in stillness, not in silence, but in peace. Try to picture it, not the end of everything, but the universe dreaming. The stars no longer burn, but their light still drifts through the dark, softly illuminating what was. Black holes, once fierce, are dissolving, releasing their last warmth into space. The galaxies have long since stopped their spirals, but the echoes of their curves are still written into space-time, like faint brushstrokes on a cosmic canvas. Time itself stretches into an almost timeless calm, where everything moves so slowly that it might as well be still. And yet, even in that stillness, the memory of motion endures. The geometry of space remains curved by every dance that ever happened. Every collision, every orbit, every rotation leaves a trace. The universe doesn't forget. It carries the memory of its own movement like a quiet heartbeat. Even when there are no eyes left to see it, no minds left to name it, that memory will remain, woven into the very shape of reality. If you listen closely, you can sense it now. Beneath all the noise of daily life, Beneath the ticking of clocks and the spinning of Earth, there's a deeper rhythm. It's the slow turning of existence itself, vast, steady, unhurried. You feel it when the world falls quiet and your thoughts soften, when your breath aligns with the pulse of the planet, when time seems to widen instead of passing. That's not imagination. That's recognition. You're feeling the same motion that shaped stars and galaxies, the same motion that gave rise to time. There's something tender in that realization that the universe doesn't end with finality, but with understanding. Its stillness isn't absence, but awareness. Just as sleep is not the end of life, but its renewal, the universe's rest is simply another transformation. It pauses, perhaps to dream. And what might it dream of? Maybe it dreams of beginnings, of hydrogen clouds and newborn suns, of the first atoms learning to spin. Maybe it dreams of light curving through the dark, or of the faint hum of consciousness discovering itself for the first time. Maybe it dreams of you, a small bright spark of awareness sitting beneath the stars, wondering where all of this began and where it will go. If the universe could speak, maybe it would say something simple. Be still, I am still here. Because in truth, nothing ever vanishes. Every particle, every photon, every thought becomes part of something else. Energy changes form, but never disappears. Motion slows, but never stops. Even when all movement fades into equilibrium, the pattern remains, invisible, eternal, waiting for the next breath of creation. Perhaps this is what eternity really means. Not endless time, but timelessness. A moment so complete it contains all others. A pause so full it holds both the memory of motion and the promise of renewal. The universe, like you, might one day wake again, stretch, and begin another turn. But that's not something we need to solve tonight. For now, it's enough to rest in the beauty of what is, to feel the gentle rhythm that connects everything, from the smallest vibration in your atoms to the slow rotation of galaxies. You're part of that rhythm. You always have been. So breathe. Let your thoughts drift like starlight, unhurried and free. The universe has carried you through 13 billion years of motion just to bring you here, to this quiet moment of reflection. There is nowhere else you need to be. The stars are still turning, the atoms are still humming, and time is still unfolding softly around you. All you need to do is rest within it. And as you do, maybe you'll feel what the universe feels when it dreams, that strange peace between movement and stillness, between time and timelessness. Maybe you'll sense that even now, as everything continues to spin, there's a kind of balance at the centre. The calm eye of all rotation, the still point of all motion. You are sitting in that centre. You always were. The story of everything, of atoms and stars, of thought and time, has been at its heart a story of motion. But motion, like music, means nothing without a pause. So now, at the end of this long, quiet journey, the universe pauses. It doesn't stop. It simply takes a breath. And so, whether your eyes are still open or already drifting shut, remember this. You are part of that breath. You are the universe, resting for a moment before the next beginning. May the universe keep turning softly around you tonight.